My name is Vladimir Izmalkov, and I'll be having this workshop for you today about technical writing and software documentation. We will have a proper Q&A session, so you can write your questions down and maybe ask them during the sessions, but feel free to send them in the chat. Maybe we will be able to notice them. We'll see. This is the contents of today's meeting, or rather today's workshop. We will start with a proper introduction of myself and explaining why I have some knowledge in the field, and we will proceed to career overview for technical writer's job. Also, subject expertise for today would be software development, so we'll be talking about that a bit, but without any deep knowledge on any programming language, so don't be afraid of the topic. Also, we'll be talking about the writing or wordsmanship, I will call it that here. And soft skills, of course, very important to communicate with your colleagues and in general to gather information. The significant topic that we'll cover is tooling, as in what tools technical writers do to actually do their job as best as they can. Also, we'll cover processes, and at the very end, we will go through a few practical demo sessions where I will be showing you how to use these tools and how a typical day of a technical writer might look like. And at the very, very end, we will have a final Q&A session. So if you will have any significant questions at the end, we will try to cover all of them. So don't be worried, we will have time planned specifically for that. We will be having a few breaks during the process, like at least 2. So also don't be worried that this whole workshop takes somewhere roughly around 3 hours. Let's get started. So hello again, my name is Vladimir Izmalkov, and let me introduce myself properly. I'm working as technical author at Canonical. You might have heard about it. It's a big company that's actually created and distributing the Ubuntu operation system, and actually a lot, like many different interesting products also created by Ubuntu, and most of them are open source. So yeah, they're completely free to use for everyone, and also free to contribute to them, as in most open source nowadays. I also happen to have a few degrees, namely the bachelor's degree, the Master of Engineering degree, and PhD, and I also member of ISTC. We will talk about that a bit later, but for now, I have to mention that I had these multiple roles of leading research teams, documentation teams, and being a senior technical writer, and probably all other degrees of technical writing. I also done that. Also tried myself as a freelancer for just a bit, and this particular career of writing documentation got me the ability to start my international career, to move from Russia in 2022 and actually settle in UK for now. So let's get started. Well, my career path was quite interesting with a few changes, and you can roughly split it into 4 sections, first of which, obviously, education. Education is pretty important for technical writing. Not mandatory, but it can give you a good basis for the future advancements. So in my case, it's Bauman University, Bauman Moscow State Technical University in Russia, one of the best ones, and a bachelor's degree in computer science and a master's degree in aerospace engineering, which I never actually worked fully for aerospace engineering, but computer science is my thing, yeah. So from the university years, I actually got a pretty fluent and decent English language. Of course, it's not specifically enough to actually write documentation fully just from the university education. You have to have a lot of practice and have this fluency that comes out of practice, so yeah. Also, just for the sake of understanding, my passion throughout my young years was always everything related to computers, being software, hardware, soldering, microcontrollers, or cloud services. Anything related to computers was a real passion for me, and still is, actually. So I started my first job out of university as a junior researcher at a research institute. So I joined academia in Russia, and I was working in interesting field of safety in emergencies, but specifically I joined the Information Communication Center in my research institute. So it was also related to computer science, fortunately, which I quite enjoyed. And from this particular institution, I got a PhD later on, also combining these two specialties, safety in emergencies and information technologies. And I became a head of my own research team there, which was quite interesting experience. But I also got from there being really, really bored with inefficiencies and bureaucracy of academia. And that's where I started thinking about how to actually switch into something different, ideally in some enterprise. And after analyzing my skills and what I've been working with so far, I understood that I actually could get a decent career in technical writing. So that's where I kind of realized that I am a technical writer by skills, and I can do the craft very efficiently just because out of my passion for IT, but also a lot of knowledge about documentation and keen eye for detail that comes from academia. So that's where I started my efforts, and eventually got offer to join a huge IT company in Russia and document their NoSQL database management system. It was very, very interesting, and I was writing documentation both in English and Russian languages, which also helped. And the database itself was actually an open source one. So yeah, you can still see it on the internet. It's called Tarantul, and yeah, part of their documentation is written by me. I was quite enjoying the process. It was quite insightful how enterprise companies work and all these agile things I kept hearing about in academia and so on and so on. So I quite enjoyed the time. And eventually I was promoted to lead my own documentation team there and to document actually quite sophisticated product, which was a cloud platform. So like huge product with a lot of components and like very interesting but very complex documentation. And I was participating actively in community of technical writers. Since it was a huge company, we had a lot of technical writers working together. And at the time, I became the head of the Technical Writers Guild, how we called ourselves, the community. It was about 40 members, so most of them were technical writers, but also some analysts and some adjacent roles. So yeah, it was quite an enjoyable process. We were discussing our experiences together and exchanging, just some tips and tricks and best practices throughout the company, even though our documentation for different products were quite different in technologies and approach and style guides. So we'll get back to all of these questions. But for now, you have to understand that it was quite an experience with a lot of different approaches gathered in the single place in a single company. And I was actively participating in the community, which helped a lot. And finally, I got to a point when I decided to move on from Russia to some international location. And eventually, first of all, I got into Turkey for some fully remote work, which was also quite an interesting experience. But eventually, I joined a smaller startup company in London, United Kingdom. And they sponsored my visa and relocation, so it was quite nice. I actually joined their company as the first and only technical writer. It was actually an interesting responsibility, and the atmosphere of the smaller startup actually quite interesting, isn't it? High intense, high performance people, highly motivated, but you have to apply yourself and do it, yeah, in a very interesting way. Engage with everyone, because a smaller company, you have a different kind of relationship, closer relationship to everyone. And after a year and a half, a bit more actually, in this company, I got an offer from a bigger company here in UK, which was quite interesting because it was canonical. As I said, authors of Ubuntu and so many different interesting products for me, including OpenStack. They have their own flavor of it. And they have all these Chant products and Juju orchestration systems. So yeah, I joined the company and still quite enjoying it. And on top of that, I actually became a member of ISTC, which is the Institute of Scientific and Technical Communications here in the UK. And eventually, I got the leader of the London branch of ISTC. We having like monthly meetups here, like face-to-face, to discuss yet again our different experiences and best practices in documentation. So you're quite enjoying my time here right now. And let's talk about a little bit about this workshop and what we will do. So don't expect this to be a complete and comprehensive tutorial or learning course for the role of technical writing. No, this is just an overview, a tour, if you may. So that's why I place some picture of visitors to the workshop. Basically, I'm not expecting you to be able to write documentation after this tour, but I will try to guide you through all, well, maybe not all, but all that I could come up with, guide you through many interesting aspects of this role to show you how it is done, how it looks like, what you will have to deal with if you choose this profession. And yeah, I hope you enjoy the experience. And this overview gives you enough context to decide whether you want to engage in this activity or not, and also to decide where to put your effort, because this role of technical writing actually, it can be very different from company to company, even from a role in the same company. Different roles could have very different skill requirements and daily activities. So yeah, I'll try to guide you through many different options this role provides. So yeah, keep listening, but you don't have to understand and remembering everything right now. I do understand that 3 hours is quite a long time, and I have a lot of information to share. So there will be a video record available, and don't be afraid. If you miss something, you can get back to it and see it again. Just try to get the understanding, the feel of it. That's what matters. So let's start with a career overview, which is a very significant part of what I just said. Let's talk about basics, what technical writers do. Well, out of the just two words, technical and writer, you can understand that we're dealing with written communications here. So basically, we are writing something and we are doing it technically. Yeah, actually, technical writers could be placed in a more general category of technical communicators. So basically, our task is to communicate some ideas or details about some product or a service. And yeah, the details can be quite technical, but yet again, it's quite different. Sometimes it's not that technical. Sometimes it's very technical, and you have to learn a lot just to be able to document it. And the main misconception that I actually encounter quite often, that technical writers do something in the line of copy editors or just any person who writes text on the internet, and they can be substituted with some AI LLM system or something like that. It's not quite true, because we do so much more than just writing some text to be published on the internet. Specifically, we actually doing a lot of research to write proper documentation, and we do a lot of planning to write it again on time for the deadline, and to align it as much as possible with the product for it to be correct and trustworthy. So a lot of preparation going on, including some interviews with subject matter experts, with stakeholders and managers, and just different colleagues of ours. We also do a lot of tests. Sometimes we can even test how product works, but it's not the goal here. The goal here to test whether our documentation aligns with the product. At least that's what our role suggested. We test our documentation against the product, and so on. Also, we do some reviews and editing and stuff like that. That's also true. So you have to be diligent about your language skills, and yeah, that could be quite important. Let's talk about why documentation is needed and which products actually need documentation and which products are not needing it. Basically, if we have a simple product, which I illustrated here with just a spoon, your users might as well use it quite effectively without any documentation. So why would they want to spend any time working with your documentation instead of the product itself? So for a simple product, it might be a good idea to go without documentation if the product is intuitive enough. But many products are actually quite complex, and they cannot be intuitive enough to be able to engage with them effectively for most users. That's why we need documentation for such products. Documentation helps the user experience to streamline it and to actually avoid a lot of frustration and errors. And sometimes some products even can't be used without documentation. Like literally, the absence of documentation can make the product unusable. That's important to understand. So for analogy, we can probably compare that to some kind of a journey, right? So we have a user who tries to use our product, adopt it into their work, and if it's a like a short journey if the adoption is quite short and it's streamlined and it feels like a short trip in a straight line. Yeah, maybe they don't need this documentation at all. But if there are any sophisticated like actions they need to perform with a product, or if the adoption cycle is quite lengthy and they need to learn a lot to be able to use the product, we might want to create a map for them to actually help them navigate through the obstacles of familiarizing themselves and using the product. That's might be very important, even critically important for people to adopt our product. So it might even influence the success of the product. So yeah, if we users cannot directly adopt the product without documentation, that makes documentation a critical part of the user experience. And that's why we kind of need this process. And I will be talking through what all these lines and arrows mean actually in a moment. So what we have there is a product and the user who wants to use a product, but they cannot do it directly. That's why we kind of need documentation. And we have these subject matter experts. Maybe that's the developers who created the product. Maybe that's stakeholders or any other colleagues of ours. Maybe not even of our company. Maybe there's just some other companies' experts that we need to deal with. So basically, what we have here is that we, as technical writers, directly engage with the product itself. Of course, it's a source of truth for us because we're documenting the product. We have to be proficient with it. We have to understand how the product looks like and what it feels like to use a product. But we also engage with subject matter experts because sometimes, again, if we're talking about sophisticated products, we don't know much about it when we communicate with it, when we deal with the product, when we engage with it. And sometimes we need even to be taught by people who knows how to use a product, some specific aspects, or even get significant help to get started, to write these examples, to write tutorials, to even understand how exactly the product should be used. That's how sophisticated products could be. And subject matter experts actually play a crucial role here. We can ask them, they can share this information with us, even teach us if necessary. So after gathering all this information about the product itself and from subject matter experts, we actually engage in creating documentation. We actually actively creating some content that will help users. And the alignment between the product and documentation should be quite close. So we should pay close attention to any changes in the product, so to accommodate these changes and to take account for in our documentation. Because it's really frustrating when your documentation is out of date and you cannot actually see the same picture that you mentioned in documentation. You cannot see it in the product. It's quite frustrating and misleading. And finally, the main error here is users engage with our documentation to get around the product, to understand how it should be used to actually improve their life. So if they will be having bad time using our product directly without documentation, the documentation should actually help them quite a lot, right? That it could lead to faster achieving what they want, to lead to better results even. So that's quite important, and we should pay close attention to this specific error actually, and to gather as much as possible their feedback and metrics, how good our documentation works for the users and their user experience. So that's quite an important one. So specifically, this career of technical writer could be potentially envisioned as some kind of a skill tree, right? So I try to picture here something in the line of a skill tree from an RPG game or something. So basically, we have these different branches of skills that we can get. I guess most technical writers need at least basic skills in every branch, but there are so many different technical writers who can specialize in different branches, and at some cases you can be expert in one branch but only basic proficiency in another one, and that could be fine for your particular role, for your particular requirements at the workplace and at the product you engaged with. So that's totally fine. You have to understand that these branches are mostly independent of each other, although there are some significant interesting relations between them, especially between tooling and subject expertise, especially if the tooling section includes Dox's code. But we will talk about it much later. For now, let's start with the first branch, which is subject expertise. In our case, for today, it will obviously be software development as a subject. So we will be talking about documenting software, basically. But it's not the only thing you can do as technical writer, right? So basically, technical writers can be doing documentation for so many different types of products. It could be software, of course, but it can also be an online service that did not require any installation or even hardware for computers. It could be industrial machinery that's not related to computers at all, or even related in some weird way. It could be medical equipment, which is quite actually a field requiring a lot of standards familiarity and even some specific education to be proficient with, because there are so many different medical related and health related standards, and documentation has to be compliant with it. Also falls into the same category. Aerospace engineering also requires a lot of standards and compliance and that kind of stuff. So basically, you can be familiar with the product. You must be familiar with the product to be proficient and to write correct documentation. But being familiar in the subject of the product actually helps a lot too. And it's really hard to establish effective communication with anyone in the field, with subject matter experts or users, if you are not familiar with the subject at all, because you're literally talking on different languages, terminology problems, and you don't understand what they're actually trying to achieve and how they usually do that. That actually gets in the way. So why you might want to learn about software development at all? There are multiple reasons. If we are talking about software documentation at the very least. So you can be very efficient in communicating with developers if you understand what they are doing and how they're doing it. Yeah, you can get a deep insight in the features that they create and interfaces that they use. You can read the source codes, which is sounds scary, yes, but it's not that scary if you learn how to do it, and it's quite useful for documentation in particular, because source of truth is a high value product here. If developer thinks they know what the product does, but you read the source code and you see that it does something different, that's a viable scenario, and you should accommodate for people's fault. Source code mostly works as intended. You might just not understand how it works. So it's sophisticated, but it's very valuable. You can also read pull requests and commit messages. We'll be talking about it a little bit later. You can produce code snippets, for examples. If your product can be used with some programming language, yeah, why not? You can produce these examples yourself. You can be using Doxa's code approach. We'll be talking in detail later on. You can automate your documentation, updates, testing, and image generation. That's also will be covered later on. And there is a lot of synergy with software developers, how you can help them and they can help you. At some point, you might want to consider learn at least basics of programming if you work in software documentation, but that's not required. That's not mandatory. Hopefully you can do without that, but you can be so much better in your field if you actually go into at least basics of programming, just learn some relevant programming language, the very minimum. You don't have to be expert in it. So how software development lifecycle looks like. So to develop a proper software, we need to go through multiple stages. Some stages can be omitted, although it usually influences the quality of such software. But for simple software, yeah, of course, we can omit a few. The general software development lifecycle, or full one, looks like that. We have stages like analyze, design, code, test, deploy, and maintain. And just put into perspective here that actual programming, as in writing the program in programming language, is the code part. So there is so much more than just programming in software development. And that's the reason why software developers usually don't like when you call them programmers. Not all of them are like that sensitive, but still just pay attention to call them properly. That's important to build the rapport. So if we talk about the programming, the coding section, it's not like you don't need any knowledge of programming languages in any other sections of this software development lifecycle. Of course, you need, but the creation of code, literally the process of you writing the program down, mostly happens there. Of course, when you design it, you can create some snippets of code. When you test it, you can find that your code works inefficiently or just have an error and you have to fix it. So you go the end user programming skills. So yeah, you use it elsewhere too. But at this point of time, here and now, like most of it happens in code, like 90%, I guess. Although it doesn't mean that most of the time spent there. Actually, testing and sometimes deploying, sometimes designing actually can take quite a while too, and quite an effort too. What happens at each stage? We actually analyze the problem that we're trying to solve and automate at the very first stage. And that's actually very, very important to plan our further actions. And of course, it's more important for more sophisticated software. What do you think? Oh, what do you think in design stage happens? We actually think about the modules, how they interact, and how to build our program from different bits and pieces. That could be also more important for sophisticated software. Coding stage is quite obvious, maybe not for the people who don't know how to program, but you basically use a programming language to write the code. The testing stage, you actually test that your code works correctly. You write specific programs called tests to work that out for you. Basically, you have strict requirements that needs to be met for the test to be successful. Deployment stage, you actually deliver your software and build it into something that could be run on a computer. And maintain stage, yeah, you actually kind of support your software after it's been delivered. What happens when you reach the end? When we actually deliver some kind of software, we usually just start over. We start a new version of such software. Sometimes we can drop the maintenance, like drop the product at all and just ignore it and do something else. But usually this cycle just repeats itself. That's literally how it works. The tricky question here, at which stage we do produce documentation? And the answer to that, most correct answer to that actually, on every stage. Every stage has something to document. Obviously, it depends on what kind of documentation we mean. Even if we talk about user documentation, we can probably reuse some of the documentation, the internal documentation we created during the analyze and design phases, and reuse this knowledge in the user-facing documentation later on. So it's all being useful, and if we are doing it correctly, like through a secure software development lifecycle or anything more sophisticated than just a simple program, yeah, there should be some internal documentation on each stage. And why you should be aware of this process? Because that's how software development is done. And if you're documenting software development, well, you might as well know all the stages and what is done on each stage and what to expect to find there. You might actually find it very, very useful when you're being asked to do something before the correct stage to do it happens. So, example, when we only designing our software, like on the design stage, we cannot predict how that software will look like at the end. We can have rough estimation and assessment how it might look, but it's not done yet. It's not being programmed yet. On the code stage, it's not even being tested and fixed, debugged, and all that. So yeah, it really, really helps if you document the software to know what's happening on which stage and which stage are we on right now, and what are the special details about that stage. So what actually software development is, for those who might be not familiar, we're talking about the source code being produced by programmers, well, software developers, but on the stage of creating the source code, they can be called programmers, I guess, in this narrow context. So they produce source code in a programming language of their choosing, or maybe that they used for their team, their framework, whatever. And the source code is basically the logic of the program written down. It's there are so many assumptions and rules there that yeah, it's more complicated for that. But simplifying it's just write down logic instructions, algorithm written down in a particular language and rules. So valid source code can be later on built into something that can be run on a compatible computer. Let's call it like that. It could be your mobile phone, it could be anything. Just pay attention to source code can be built. This is an important step, which we will be talking right now. So basically, there are stuff like in programming languages called compilers and interpreters who actually build your software. So the Software developers at the coding stage create source code, and this source code combined with other resources, well, literally some images, sometimes it's libraries or pieces of different code that we reuse, all of that like together as a package being produced by a compiler or interpreter into some runnable software. In case of interpreter, it could run it immediately, or compiler, it could produce a runnable file like exe in Windows, executable. So that's important stuff. We have source code which can be built into something runnable. And that's how it looks like. Basically, we have some version of our source code. We programmed our very first version of the program. We build it with our compiler into executable. So that's a program now that potentially could be ran. But then we change something in our source code. We create a version 2, version something else of our source code, and that could be built by the same compiler, presumably into the version 2 of our program. You see, there is a direct relation between the source code we produce and the program we build. And the compiler, well, it could be updated or changed in the process, but usually it's not what's changed. The changes are in the source code. So, well, software developers kind of tend to automate this stuff through a CI/CD pipeline. So basically, they put their source code in a repository, Git repository. We'll be talking about that a little bit later. And they use automation for every update of the source code in the repository. They automatically build a new version of the executable, their program. That's super, super useful. That's called CI/CD pipeline, or like just automated builds. And we will be talking about that again later in the context of Dox's code and how we use that approach to build our documentation. So let's talk about these repositories I mentioned, and specifically you might have heard about GitHub, which is quite popular, or some of you maybe even heard about the Git itself. So what we have here in general is version control systems who are used to track all the changes in some content. And to tell you the truth, the content is usually just text files. That's quite important. We will get to it later. So basically, when you create your source code, it's just a text file. You store it in a repository to track all the changes. So anything like every operator, every variable name, every sign there is tracked. And if you change anything, it will track these changes. That's required for the versioning. So basically, if you have version 1 with some error, then you fixed an error, so you created a new version. So this version control system helps you to track of all the changes and all the versions of your source code. That's super, super important. And the way it does that is through interesting approach with branches. So you have your main branch, and how we used to call it master branch. And in this branch, we kind of think of mainline version of our product. And to apply some changes to it, we usually just branch out, just create new branches out of it. We work in these branches. It's like a parallel universe of some kind. You work in this branch, and usually it's only you who make changes to your own branch, and you make some changes. Literally, you fix something, you add new features, you just change the product any way you see fit. And then when you kind of ready, when you think that, yeah, this work is done, I implemented the feature, fixed the bug, or whatever I wanted to try to do here, you merge your branch back. So merging of branches actually puts the changes you implemented back into the mainline branch, or the branch you chose, actually. So in this case, on this diagram, you see how our work can get merged back into the mainline, main branch, master branch, whatever we call it. So someone else in parallel could be working on their own changes, on their own features, and our merge should not obstruct their work, should not violate their work in any way. So it's this branching system actually helps us to collaborate together and to merge our changes. And even if there are conflicts, if they change something that we changed, so literally it's their word against ours, they change against ours, to be specific. Even in that case, version control systems and merging of branches will help you to resolve this conflict, and will help you to specifically address what needs to be resolved, like which lines are you conflicting about, so you can manually adjust which version would be the final after all the merges. And what's great here and why it's important for documentation too, is that originally all the source code is in text files. As I said, it was created back in the 2000s, originally for developing Linux kernels. So it's very, very reliable at tracking all the changes in plain text files. And yeah, plain text files could be used not only for the source code of your program, which is actually true, it is being used for that, but also text files could be used for your content, for the content of your documentation. That's exactly what we do in Doxys code. We'll get back to it later. But for now, this interesting concept of version control systems like Git, I like to put an analogy on that as a game of chess. When you play a game of chess with some professionals, you usually tend to write down all the moves. So imagine if we could go back and say, okay, what if on this move, I will do that instead of that? You kind of branching out into parallel universe, you kind of work there a bit, and you think, oh yeah, it would work better, and then you merge it back. So you merge the reality, the parallel reality you created back into the main reality, but then you see that it conflicts, that in main reality, someone already made some change that is conflicting with your change. So you have to resolve, you have to deal with that changes manually and say, okay, we'll leave that one. You see, so you kind of creating these interesting parallel universes and then merging them back and then resolving any conflicts. And Git or any version control system helps you with that and doing it quite effectively, because software developers do that for source code. It's quite sophisticated, might can get quite complex, so they actually develop quite a system, I would say. It's very reliable, it's very accurate, so yeah, a lot of problems being solved here. This is the analogy I've made about the chess play and all the moves being written down. Let's get practical here. I mean, we have the Git, right? We have to use it. So Git actually works on client side and server side. You usually have your server side where you store the remote or so-called remote version. So you have your repository that you publish somewhere. The most popular one is GitHub, the portal to actually host your repositories. It can do that for free, so I totally recommend getting an account there. But there are alternatives like GitLab, Bitbucket, and some companies, some bigger ones, can even create their own self-hosted service. So instead of paying for some service to host the repository, then literally can host them themselves, for example, in their secure environment, not available for anyone outside, like they're just protecting their source code from the external hackers or something. So you don't need to know a lot about that. They will deal with that if you work for them. But GitHub, totally recommend. The client side, though, can get quite tricky because the default client for the Git, it's actually command line tool, which you can see on the bottom right. It can be quite sophisticated because you need to know all the commands. You need to understand what's going on. Yeah, it can get tricky if you learn it first time. So I totally recommend the second option, the GitHub Desktop, which we can see on the bottom left, is an official GitHub graphic user interface utility, which works not perfectly fine, not as powerful maybe as Git, not as many advanced features, but you don't need them. Just to start, GitHub Desktop is quite good. It will make things much easier for you. So just your very first steps would be so much better with it. On top of that, there is a third option you can consider for the client side for how you can interact with Git. Basically, integrated developer environments, being the sophisticated text editors that software developers use to code, to actually create their programs. These integrated developer environments, well, they already work as text editors, right? So we can use them. And on top of that, they can have this integration with Git, so they can deal with that stuff like from the same interface. Nice, right? So that's how the command line interface Git looks like. You use commands like git pull, git add, git status, git log, git push, merges and branches and checkouts and so on and so on. This is how GitHub Desktop looks like. Much more user-friendly, I would call it, right? At least for those who prefer graphical interfaces. We have the history on the left open. We can see the changes if we want to switch there. We can select our repository, our branch, and we have like literally a single button for most of the actions we perform here. So yeah, quite interesting. This is how integrated developer environments looks like. So basically, we have Visual Studio Code, quite popular nowadays. You have your navigation panel on the left, your source code in the middle, and on the right, at the moment, we can see a preview of a file. Basically, that's what we do in Doxers code. We have a preview on the right, or somewhere, actually, and we write the source code of the documentation right here, watching the preview if we need. And this is how IntelliJ IDEA and other integrated developer environment looks like. And I actually prefer this one. It's just a matter of preference, really. But I like this one more. And yeah, pretty much the same experience. We have a preview, we have a source code, we have our navigation. And if you like attentive enough, you can find on the bottom right, there is a little icon for the branches, and there is a name TypeQL modifiers, which is the name of the branch I was using when I took this screenshot. That's exactly it. That's the integration. And yeah, that's mostly about the Git. I will not go into much detail on how to use it right now, although we will have the practical demonstration at the very end. But there are so many courses. You can find a proper tutorial and learning course about Git if you need, and I totally recommend doing that. Super useful. Let's move on to the next topic of ours is API and how to document it. So basically what we have here is a interesting ability of using another interface. So we were just talking about graphical user interfaces and command line interfaces when you type your commands into a console. That's another type of interface. It's called the API, or application programming interface. That's used by applications to talk to another applications, or programs to talk to another programs. And by analogy, if you don't know what that means, that's a role similar to maybe a waiter in a restaurant, when you actually have your kitchen and your chef cooking, and you have your customers, and you need to connect them. You don't want your customers to go directly to your kitchen and mess something up. You don't want to let them in because of the security and safety reasons and so on and so on. So you have your waiter who actually simplifies the process for customers. They just need to tell the waiter what they want, and waiter will deal with everything else. You see? So API for some backend servers, like a database, could serve the same purpose. Some front end, for example, your web interface or your other interface or your program, could send a request for some data to API. API will be implementing this manual request to a database to gather all the information required, and will produce an answer in a format that is expected from the API to produce. So there is some room for documentation here, I can assure you. If we talk about what an API specifically is, like a definition, it's basically a protocol, a set of functions for interacting with software components. Very bland. I really like the explanation or analogy with the waiter more. It enables you to request data or services from another computer program or system or whatever. So basically, if we are talking about documenting API, most of the time, not always, but most of the time, you will be dealing with REST API, just working over HTTP, like the web technology we use for websites. The same could be used for these APIs. That's like more than 90% of all APIs being used nowadays and being documented nowadays. So these kind of APIs, they expose specific endpoints, basically addresses like you put in your address tab. These addresses could be used to make a request. So you send a request to that address. The request is sent via typical HTTP methods, the same being used for websites. These methods like get, post, put, delete, they're quite obvious what they do, right? There is still documentation about that if you want. And the point is that you get a response. Sometimes the response just acknowledges the operation you requested to do. Sometimes the response is just an error. But sometimes if you requested some information, the response for your request can contain such a data. And the usual output formats for REST APIs is JSON and XML, JSON being much more popular nowadays. So that's most that you need to know about APIs, but we can continue a little bit more in a practical side. From practical perspective, API could be seen as some kind of control panel. So behind the panel, you have all the wirings, all the mechanisms, all the motors and the electricity going on. But on the panel, you just have a nice handles, nice lights, nice indicators, more humanly understandable than just a current in your wires. So yeah, that's best analogy I have for you. Some examples of what APIs can be: basically connecting front-end interfaces like your websites or applications to the back-end systems like databases and storages. Enables some third-party services integration, like you can integrate a payment to your website or social media sharing functions. You can be just another interface, like I told you, in the line of graphical user interface and command line interface. It's just an interface designed specifically for machines, for your programs to interact with other programs. So one particular example, imagine a weather application. So the application that uses some API to request some data from weather servers that store it and maybe even produce it on like super machines, just model the weather and know what weather will be, like the future they predicted. So you request from them this information that they have, and the API that you using to request it sends back the data. Maybe it's temperature, humidity, maybe it's whatever else deemed necessary. But the point is, it's a request and response system usually that you use. So some tools you can use to actually work with APIs. Obviously, you can use some programming language. That's intended purpose of API, but that's not why we're here today, right? We're not talking about software development and programming in general. We're trying to avoid that if possible. So there are some other tools I need to mention. For example, the command line tool, very popular one called curl. You can see how it's used right there. So you basically specify, like you call the function right in your console, and you specify parameters with which to call it. In this case, it's a verbose parameter, which will show us the output and the address where to send the request. It could be much more than that. So it could be like all the headers and bodies and all the parameters for your request. But it's very, very neat and tidy, as in you can copy the command itself, even if it's big, paste into your console, and it will send the request. It's very nice to do that. Also, there are some graphical user interfaces like Postman and Insomnia. We will see them in a minute. Oh, sorry. This is how curl looks like. Like I said, you paste the same command, which we just saw, into your console, and the response will be quite verbose because we use the V argument here, which is specifically for verboseness. And we see the response. So what we see here down here is basically the response, and the 200 code is actually successfully code. Basically, it's called OK. It is a correct response from the web server that we requested. So yeah, it's working nicely. This is a graphical user interface one. So that's how Postman looks like. Totally recommend. It looks scary, but it's actually very easy. You have your request, you have all the fields here, and basically, yeah, you can send anything, you can get the results, you can see them clearly. So just if you understand what an API is and how to use that specific request, and to understand that, you need documentation, which you might be tasked to create. This is another tool, very same to Postman, just looks different. It's called Insomnia. So that's basically it. You have list of queries, you have your query body, you have your response, and like, yeah, it's super easy, really. This how actually automated documentation for these APIs looks like. So basically, if you want to create some kind of documentation for API, the best practice at the moment is to use it automatically. So by specifically using some comments inside the source code, programmers or software developers, and again, we don't call them programmers usually, software developers put these comments in their source code for the automation to know what to write here. So you see this add a new path to the store would be a comment inside the source code. Specifically formatted comment, yes, so there are rules, but the best part is usually software developers do that by their own. They know the rules. It's quite easy. It's called open API specification, what they need to follow. And if they do that, we have the tools, we have the technology. It's called Swagger UI in this case. So basically, it can help us build this neat page, which is quite standard, and people already know how to navigate it, how to use it, how to read information about each request for the API. So that's basically what I wanted to tell you about the software development part. I know it's a lot, but like I told you before, that's it's not like you're supposed to remember and understand everything here. There will be video recording. Get back to it, and yeah, we will have a Q&A sessions also too. Now we will talk about wordsmanship, or actual writing, and how you do that. And let's start with the language proficiency. You can write in so many different languages. I did write documentation in Russian, in English, not myself because I don't know many other languages. So yeah, it's not that different if you think about it, although of course the proficiency in which you can use the language is a factor here to actually understand and accommodate for, I guess. So obviously, if you like write documentation, you make a lot of mistakes, silly mistakes that undermines trust in your documentation by the users. When they read documentation that is poorly written, that is just doesn't look right to them, they have the suspicion. So yeah, you might want to advance your language skills if that's a problem for you. Also, we have to optimize documentation for it to be easy to read, but we must be accurate in our documentation. So there are two factors here: the accuracy being the mandatory, and the easy to read will being very important, but still after the accuracy, I think, because it's technical documentation, it has to be accurate. And natural language for you when you write anything, and including technical documentation, would be your professional tool. Your scalpel, if you may. You might as well learn it to some high degree. You might want to become, not a Shakespeare, of course, but a significant expert in terms of how to write stuff. But there is a factor here that limits the high bar. The factor is thing called international English. You have to understand your targeted audience. If your targeted audience is international, general public, and you might expect not all of them being native English speakers, so you might as well not use sophisticated phrases, sophisticated words. So you might as well try to simplify your text for people to be, able to understand you correctly, and easier for more people to be able to understand you correctly, not only native speakers. So you have to watch all the idioms you use, all the phrases you use, how sophisticated they are, how you can understand. So even if your language proficiency is not that great, that might be a factor playing some benefits for you, or providing some benefits for you, just because you have a better understanding of problematic places. If you don't know some phrase or some word, what it means, maybe some other people might not know it. There is a possibility of that. It's a tricky business here and a slippery slope road. But still, you have to accommodate for people not being native in the language you use, especially if it's English, because it's being widely used internationally. Just consider your audience. Sometimes it's less of a factor. And at the moment, what I would say, there is a great effort has to be put in to write something in fewer words rather than many words. And that's actually a very important topic, because your documentation should not be wordy. It should be quite short, concise, quite accurate. So yeah, sometimes you have to spend extra hours just to make it shorter, just to remove words. So you're not being paid for each word. You have to understand that. That's quite the opposite usually. AI writing, obviously a great factor here. You might have heard about these LLMs that can create text for you, and that's a huge problem for documentation. That's also a big sin, like figuratively speaking, of course, but still, it's quite a bad practice. And if people notice that you use AI to write some content, and it's quite obvious that this text that you presented or produced documentation with is AI written, yeah, it's a great shame on you. It's so bad. It's like, yeah, it's great problem also from technical perspective, from many perspectives, because the content being produced by AIs, it's quite inaccurate, and frankly speaking, it can be misleading to the point of complete and utterly wrong information being very persuasive. like AI should be considered from all sakes and purposes for you as technical documentation specialist. They should be considered chronic liars who were trained to cover up their lies. That's basically how we deal with them. AIs are bad. You have to be very, very mindful of how you use them, and you can use them. There are some AI spelling tools, like Grammarly, I believe, uses AI at some point, that can help you improve your spelling and find some errors in your text. That's fine. You can use it, although it still can produce some wrongful fixes sometimes. So just pay attention and advance your language proficiency as much as you can. And also, you can potentially ask AI to rewrite some stuff. Hopefully, it's a smaller stuff, like a paragraph or a sentence. You can ask specific goal, basically rewrite it for clarity, rewrite it for shortness, just make it shorter, just rewrite it in this kind of line, like more engaging, yada, yada. But you have to understand that it's a good idea to actually ask only the questions you know the answer to yourself. If you don't know what the correct answer looks like and what you want actually to get, and you ask AI to do that, the result the AI produce, it's really hard to distinguish whether it's a hallucination of AI or it's a correct result. So yeah, it's never a good idea to ask AI questions that you don't know answer to yourself. Why you might want to ask questions that you know the answer? Well, that's because sometimes you just don't want to pay additional effort and time just to rewrite something and to find all the synonyms and to think about it for like half an hour. Yeah, you can do it faster. That's it. And that's totally fine as long as you control it. The writing part of our job is actually quite interesting because it's quite different from what other writers do. And usually when you tell people that you are a technical writer, they can imagine that you are writing a book or something, but it's not a book. You have to understand it. Any documentation is very different from a book because you're not expecting people to read it from top to bottom. The most difference comes from the usage of your documentation and the implications that it applies. You actually use documentation to skim through, to navigate through the information, to find exactly most relevant at the moment information, and to specifically find guidance and help in your situation to advance as soon as possible. So the least amount of time spent to solve your exact problem and to move on. Maybe to the next problem and to come back to documentation, but still, it's iterative approach, and that's quite important here. So you might optimize your documentation for exactly that. You have to pay attention to meaningful headings. That's quite important. You have to pay attention to overall structure. That's also very important. You might also master the skill of using lists, tables, admonitions, examples, links to properly structure your information and to highlight important information, because just a list of text without anything on it, it's really hard to navigate over it. If you put a lot of clues in it, you have to find some information. For example, a list or a table, it can structure information. In a table, in each line, you expect the same amount of columns, and that helps. That's actually very, very helpful to structure information. So when you use all your best judgment, you have to understand that all people are also different. They have different perception, and what most people can find, some people cannot. So just check your assumptions. Sometimes it can be done only through gathering some feedback, metrics, and doing proper user research to find these problematic spots in your documentation that you cannot see, but other people do. That's the point. So researching interviews, that's quite an important topic. One of the interesting parts of our work is interviewing subject matter experts. Basically, you talk to a guy you talk to a person, right? Talk to a person who knows a lot, and you have to have their knowledge. You have to ask some questions. You have some probably missing gaps in our documentation that you want to fix, or you just don't know anything about new feature that just been released and you need to create documentation for. So you have to interact with them quite efficiently, because their time is very, very expensive. They are experts and being paid as such. So they're kind of busy. They're busy creating new features while you asking them to spend more time on documenting the other features that they already created. So yeah, that's quite annoying for them. You have to minimize the time they spend, and you have to come prepared to these meetings. But how to prepare is to think about, at the very least, these three most important, I believe, questions before starting work on your documentation even. The first question, what is a product? And you might think it's an easy one, like you might as well know what is a product, but it's actually a tricky one, because you have to understand specifically what you document. If it's a new feature, which version of the product it's been released with. If it's a new version that's not been released to the general public yet, you might as well know that to properly accommodate for that in the documentation and not release it before the time, right? If it's been released previously, in which version it appeared, you might create a note here that it's only available in this version of the product since like 2.5, for example, right? So you have to understand the specifics of the object you're documenting, of the product, basically. That's what this question is about. What is the goal of this communication? That's super important, because you have to understand that documentation is not always explaining just a bunch of stuff. It's about achieving some communication goals in the line of, you can have a goal of actually teaching people how to use a product. That could be a great tutorial, and we'll get back to it. But you can also just want them to do some specific thing by step-by-step instructions, that could be how-to guides. It's very different. So you have to understand what is the goal of communication. Is it to deliver some reference information to them, or teach them something, or guide them through some step-by-step process, or explain something to them? That's very different in how you could solve this goal, how to achieve this goal, how you could solve this challenge. So the targeted audience is another great question. The third one, I believe, also very important. If you have a targeted audience, general audience, like very different people with a different experience and different level of understanding of your product and its subject, yeah, it's quite tricky and it's quite lengthy. You have to explain a lot and so on. But you can have a targeted audience of senior software engineers, when you can assume some degree of proficiency in the subject. You can assume some knowledge of terminology. You see, you can accommodate for that. You can write different kind of instructions for them. So these questions are not enough to gather all the information, but they're great conversation starters, and you have to ask them yourself and try to answer them before you even meet anyone like subject matter experts. And then if you encounter any problems, or when you encounter them, when you have some gaps, you ask SMEs on the interviews how to do that. We'll get back to it later. But you have to understand that the time and effort that you and SME put in this is limited. We quite often don't know the full limit of what we have, but you have to understand that it's a scarce resource. Okay, how to build efficient communication. That's a very interesting topic, and we don't have much time to talk about it, but typical problems you can encounter is that people tend to be hard to find something specific that they are looking for in your documentation. That might be a problem with navigation, or your headings, or just structuring your information, or just plain and simple adding search field in your documentation website. Who knows? There are so many different problems, but usually you have to pay attention to navigation and structure in this case. If it's hard to read, or people just have burn out and don't put much effort into reading it through and thoroughly and until the point they actually achieve something, that can mean that it's high cognitive load. So you might want to simplify it a bit, maybe add some examples and explanations and stuff like that. Yeah, it might be you're missing some context and they just lose the chain of thought here, or cannot visualize it with an example. So many different ways to do that. It might be just too long, so too many examples or too many explanations. That's completely boring to read for them. That might be a bit of an error of targeted audience selection. Maybe you just being a bit wordy and you need to shrink it a bit. And the last, but one of the most important ones, your documentation or your communication might be misleading, inaccurate, wrong, or outdated. That undermines the trust. That's counter-efficient. That's a very huge sin. Yeah, you might want to avoid that as much as possible. And yeah, the SAS doc here, I think, approves this message. Efficient communication comes out of solving most typical problems. So you can be efficient only if these problems addressed in some way, at least to some degree, that people find it's easier to read, easier to find documentation, not too long, and it's accurate. That only in this case you can talk about that your communication was effective, and to which degree we cannot assess the degree of efficiency, but we can think of it as if users have a budget. They have a budget of time and effort they put into reading through your documentation. And this budget is different. Don't get me wrong. For different products, it's different. For example, if it's an interesting professional product and your target audience is professionals and they actually paid already for the product, you might assume they have a budget, at least a bigger one, because they have this commitment already. If your product is free, like open source, if it's doing some simple stuff for general audience, yeah, you might assume your budget is very scarce, like minimum budget. You might as well get straight to the point, or people will get lost or bored and just don't care enough and skip it. And this is one great advice I can give you to structure your information is to use the diataxis approach, the diataxis system, which actually great. You can find more information about it on this website, diataxis.fr. You can Google it really easily with this name. It's quite popular nowadays. The best of it is actually that it's quite easy to understand initially, but it's quite deep if you know it better. So basically, you have to structure documentation in 4 different categories. Is it a how-to guide? Is it a tutorial? Is it explanation? Is it a reference? Basically, only these 4 categories of your documentation, of documents in your documentation, of artifacts. And each of these actually pursues different goals, right? So you see here axis of action, cognition, or acquisition or application of knowledge, basically. And yeah, if you're really looking for some learning experience, it's a tutorial. If you just have a particular goal in mind that you need to achieve by step-by-step guides, it's a how-to guide. You see, it seems easy, but all this navigation, when you decide which type of document you have, that has some implications. And diataxis is about that you might optimize your document for this selection. So as soon as you decided by asking the questions I mentioned, by figuring out which your targeted audience and goal of communication, you can gather all this information and decide which type of document you will be doing, and that solves a lot. You can optimize this document to achieve this particular goal, so it will be more efficient that way. That's super important, and yeah, totally recommend. One more topic to cover here is a style guide. We actually have style guides, which are quite interesting topic, and you can see a style guide like a set of standards or best practices and guidelines to maintain some consistency in your approach to documenting stuff. So that's especially important when you have a bigger team, when different people write different documents or different places of the same document, like different sections, different just features, describe them differently, right? So these people, well, they think differently. They have different approaches. They might as well do it differently, and then you will have documentation which is written in different ways in different places. It doesn't look great. You have to be consistent about it, and it actually helps a lot to navigate, to find information. If it's all consistent in its design, structure, formatting, spelling, terminology, it's so important. Actually, you cannot underestimate it, especially in bigger teams, especially in bigger sets of documentation. So style guide can help solve all that. Well, if you follow it, if you have it and follow it. Having it is not enough, unfortunately. But also it can solve a lot of conflicts. When you have multiple people and each of them want to write things a little bit differently, you can solve conflicts just by pointing to style guide. Well, we have a rule about that. That's the source of truth. If you want to change the rule, let's discuss that on the proper meeting that we have to discuss our style guide and change it. Yeah, why not? So yeah, style guide can define the tone of voice, the formats you use, the spelling, terminology, structure, and so much more. You can put anything in your own style guide, but you don't have to. You don't have to put too much in it. It's not very efficient, and on top of that, you don't have to write your own style guide at all. There are many popular ones that you can use just directly, use their style guide, or you can extend. You can write your own style guide and start with the passage. So yeah, for everything not mentioned on this style guide, use this one, like the Microsoft Writing Style Guide or the Google Developer Documentation Style Guide. They're great. I'm not recommending the Associated Press one or Chicago Manual of Style if you don't know what it is. So it's probably for more professional use, but you can check them out. let's get back to soft skills, which is the next section. Uh, what is a soft skill for those who are maybe not familiar? Well, yeah, I'm not sure, Jeremiah. We will have a QA session later on, so write down your questions for now. So what are soft skills is and why they are actually important for technical writers. You might as well understand that you're not doing just the written communication, just the documentation. You're quite a lot engaged in these communications, both verbal and written, with software developers, stakeholders, subject matter experts, other technical writers, and all other colleagues who can actually provide you with information or request some information from you. So the efficiency in which you can participate in these communications actually comes into play. And that's what soft skills are about being able to interact effectively, well, harmoniously with other people. That's a very vague area, I understand, but still, soft skills is something that lets you to get along with most people and, to just get this communication straight, get clear message through, and be effective about it. So don't spend too much effort and time on each communication, that kind of stuff. That's kind of important for main reasons. You will talk a lot with engineers and subject matter experts, and these communications with them actually could be very tense and sophisticated because the product can be quite complicated, and no one actually written the documentation before because you're doing it. So yeah, communicating with them can be very tricky, especially since if a subject matter expert is quite an expert in their field, they're usually not being paid to have these soft skills. That doesn't mean they are meanies or something, right? But just take into account that they are quite sophisticated people, quite intelligent, quite often. Still, they kind of tend to work a lot in engineering, in software development, in some other engineering fields. And sometimes they just miss these communication skills. Sometimes the soft skills for them are quite lacking. And since you are kind of a technical communicator, it's supposed to be your job to communicate with them efficiently, like effectively gathering all the information with them and just building rapport and all that. So from their side, their contribution to this discussion and their knowledge. From your side is literally organizing the discussion, organizing everything, noting everything, and also building these relationships with them that you can effectively work with them. That's literally your job, is communication. In this kind, it's not about documentation, but about interviewing, but still, it is expected out of you. It is expected from you, rather. And also, there is an interesting topic that there are cognitive biases that are basically they're common for most people. I don't believe there are any people who cannot experience some of the cognitive biases. And you, as again, professional communicator or communication expert, at some point of proficiency at least, you should be aware of them. You should take them into account, and you should be able to adjust your communication. You should be able to notice these biases, fix them, to clarify, to provide additional questions, to talk this through. That's your job. And most notably, if you want to read more about these cognitive biases, you can Google just confirmation bias or cures of knowledge. These are the most popular ones, but not the only ones. So the important step, an important, not the process, but important event happening between you and subject matter expert is an interview. Interview is a concentrated communication. Basically, they it's a planned event, right? So they kind of spend some time on you, and quite often they are there to answer your questions rather. And yeah, if their attention is not exquisitely yours, they're still quite ready to spend some time and effort. So as I was saying previously, there is a budget, and during this interviews, you kind of spend that budget quite a lot. So you should do it correctly. And the correct way to do it is actually to understand that SMEs, while they are the best source of truth about the product, they are not the perfect one. Meaning that what they understand about the product is not 100% how the product works. There's still people, they can make mistakes, they can have some misunderstandings and they just don't know something. That happens not too often, but still that could happen. So the ultimate truth, how actually your product works, is written in the source code, and how it is being executed, although it's a tricky business to read that source code, right? So basically it's not even your business, it's not your role, at least not your role responsibility. But they, subject matter experts, they usually tend to read the source code better than you. So they can do that. They can double check their own ideas when they talk to you about how the product works by looking at the source code for you. That's the best approach there is. Like they have some understanding and they double check their understanding against the source of truth of the source code. That's the best. So an interview session with SMEs should be maintained and organized by you. You're responsible for the communication. Their time and effort is about the product itself, the knowledge about it, not about communicating that knowledge to you. That's not in their job description, literally. So you should prepare for these meetings. You should prepare for the interview. You should do the research and find out about the topic as much as possible from the offline sources. So not from actively engaging into discussions, ideally, and spending the time of specialists and subject matter experts, but rather reading the existing documentation. Maybe it's older or internal one not published. Maybe it's just badly written notes somewhere, maybe even comments in source code. But you should do your research. You should gather as much as possible this information. And that actually helps you to save time. You will not ask some of the questions you already found information on. And maybe even more importantly, you will build this discussion in a very different way. You will ask them for a confirmation of information you already found. You see, so instead of asking a very silly question of how something works, you will ask something, oh, so I read that this does that, and what's next? Like, what is the next step? It's not written there. You see, it's a very different approach. It gives them context, that gives them some feeling that you did some research, that you paid attention. You're not just, oh, how does it work? Like, it shows that you pay attention, you care about, and you actually invested into it. So it's on many levels, even on psychological one, a very good idea. What else? You have to be very attentive on the meeting, on the interview itself, of course, and hear what they have to say, and to respond correctly, and to use that information during the meeting to show them that you are listening to them attentively, like active listening thing. But on top of that, you should make notes. You should write something down, and ideally, in many cases, it's a very good idea to do a video recording. If you're like on Zoom meeting, or like we are on a Google Meet call, yeah, why not just switch on the recording? Of course, you can ask them about whether they're okay with that. But having a record actually very useful, especially for sophisticated products and for subject matter experts who actually talk very fast with little additional detail because of the curious of knowledge. They assume you know something you might not. So you kind of listen to them and you understand, well, at the best, 50%, at best. So you might want to go later on to the same video recording, find things you did not understand and did not, cover, connect, anything. So it maybe even misheard. And just analyze them a bit more, maybe Google, maybe just rewatch a few times, and that will make you understand at least like 70, 75, 80%, just more. So you will get more information for some SMEs. You will avoid some of the common mistakes and just simple mistakes of not hearing or not noticing something. That's super important. What else? You should build a relationship with subject matter experts, especially if you expect to work with them repeatedly. If they build in the product you are documenting, you might expect a regular meeting occur between you, like to document every other feature, maybe every feature. So you should build this relationship, you should build rapport between you and them. And by building these relationships, that actually improves your communication quite a lot, because when we actually feel confident, when we feel safe around the person, when we understand how they usually communicate, when we understand their habits and their ways to do stuff, it makes us rely on them much. That makes us to communicate in a very particular way, adapt for their style of communication, and that helps you work faster. So again, the budget of time and effort gets spent more effectively. So, but also you can get more detail. They can clarify things that you usually tend to ask them again later on. They can anticipate that you will do some research in some areas, so they can meet them and cover some more important topics. You see, they can adapt too. Just rely more on your own soft skills. That's what you can control. So the soft skills I was talking about just now, they can be used in some advanced ways. So not only for just what we say in interviews and so on, but also collaborating with developers, pure and simple. You can persuade developers into writing the docs for you. Yeah, right. It's not even uncommon. In some companies, including my company, Canonical, it is a proper procedure of engineers actually writing the documentation for other engineers. So we have a targeted audience of actually also software developers and engineers. And why not let our developers to write documentation for other developers? That's only logical. So that's a great idea, right? Right. But they are not professionals in communication. They can write only as good as as they randomly can. Maybe they are not native speakers and they make simple mistakes. Maybe they are native speakers but just don't like writing texts. That's why they are not doing that for their job. They are mostly writing code. You see? So you have to manage the collaboration, their contribution, either by rewriting the stuff they write or just double checking, reviewing, or pure and simple teaching them how to do stuff, maybe mentoring them. You see, this approach actually quite actively being used in Canonical and some other companies, and that's very, very helpful, but it's an advanced topic. We will not cover it in detail right now. So what else you can do with advanced level of soft skills? Community management. Basically, when you write documentation and your community engaged with this documentation, use it quite a lot, it's only natural that they will have questions and feedback. They will provide that, and you might as well build some kind of dialogue. You might request additional feedback or provide them with some answers, and they will ask additional questions. You see, that's a path to maybe adjacent career of community manager, yes, but sometimes technical writers also do that, especially in the smaller companies. So in my previous company, for example, in the startup, I was doing that. I was answering all these questions about the documentation and even about the product in our support channels, in our just user community channels and so on. So community management is a thing, and it's quite great. And soft skills actually let you do that in a very interesting way. It's quite related, I can assure you. Then career progression and leadership. That's actually interesting topic because well, yeah, if you understand how soft skills works and you have the skills, you can convey the message better, you can express yourself better, you can build rapport and build relationship with people. That's a great start to build your career. So you can talk to your superiors, you can show your qualities, you can build trust and rapport. You can also manage expectations. Is a very important topic. And yeah, with all that, that's a clear career advancement goals here. Noticing. Yeah, Williams, Jeremiah, we will get the Q&A session later, so write down your question if you can. In the technological evangelism, another topic, you can build, this knowledge about the product and technology and promote it among engineers. Like it because you know it, but to be able to do that, you have to have two very advanced branches of the skill tree. One of them is the soft skills. You have to engage with the community very efficiently, and that's like a very advanced category. That's a very advanced skill level. But on top of that, you have to have advanced level of knowledge. So you have to have this insight into a product or technology, how to use them, and how to use them in different use cases for different products and situations. You have to compare it to your competitors. You have to compare it to some other use cases that might, also compete with the one you are trying to cover. So yeah, that's quite tough. We will not cover that in detail, but you can Google it, I guess. We can build a personal brand and publicity. That's also quite important with these soft skills. You can do exactly what I'm doing right now for you. You can have a popular, meetup, a workshop. You can just have a mentorship sessions. I have a mentorship on ADP list if you're interested, by the way. So we can meet with you, and that's done well for different reasons. For example, I just like having a conversation, especially in English, to train my non-native English language. But also, it can help building your personal brand, as in. Different employers will notice you, even just your colleagues by the field will notice you, and that leads to some great offers, because the best offers, they are done not through you applying for the job. That's a trick you might have heard somewhere on LinkedIn. The best offers are done through your publicity and personal brand. And the last one, which was a question mark, growth mindset, because advanced usage of soft skills will get you to the point of understanding yourself a little bit better. And it can put you into perspective on understanding the importance of growth mindset in yourself as well as others. So building this growth mindset in both you and your colleagues and co-workers, that can be quite important and quite beneficial for you, although it's not a topic of today's workshop. So that's all for that topic now. Second, yeah. Tooling. We will talk about different tools we can use, and that's a big topic. We'll start without we start with the publication format. So basically, we have a documentation. Documentation serves a purpose of being read by users to help their user experience, right? That's the definition of it, I guess. So basically, how do they read it? That's an important question, because there are different technologies, actually. The most popular nowadays, and the one that is most advanced, I would say, is HTML. And HTML is a format, if you don't know, in which web pages are done. So basically, not specifically HTML, but mainly HTML. We're talking about generally any web pages being used as documentation, so a documentation portal of some kind. And that's actually very, very flexible, very adaptable, very reliable way of doing this kind of communication and documentation publication, right? And it has so many advanced features, especially if you do it the right way, which is a Doxys code. I'm just saying, we will get back to it later. Yeah, it actually provides a very unique, I would say, benefit, which does not come with other types of format that is listed here. And the benefit is that you have web metrics. So basically, you have this Google Analytics or any other measuring platform that gets you information about who reads your documentation and how. That could be very insightful, very helpful, especially for bigger products. So yeah, HTML totally my favorite. The next one, and I tried to sort them in some arbitrary order in which I would prefer to do it. So it's not like the best to the list good, but still close enough. It's, by my opinion, is. So HTML is best in my opinion. Then we have a PDF, which is quite good format actually. It's a file that you can send anywhere, even offline systems like somewhere secure or on someone's personal device in the field. So yeah, it's quite reliable, and the PDF format itself is quite reliable in presentation. So basically, how it looks for you, it will most likely look the same for your users. So not much of inconsistency here. It's a good format. Yet adaptability is not great. You don't have interactive content there at all, but you can have it on HTML. And you have some problems with updating your content. So if they have an older version of the PDF, how would you deliver the newer content? Okay, so you need to version your PDF. So now, while they have a PDF, they might want to double check which version of the PDF they have, because it might be older one, and the content they are looking for is in a newer one. You see, so it's quite a problem. That's why PDFs delivery systems usually try to rely on the product itself, Maybe you can download the PDF from the product like via link. Maybe you can even see the PDF in the distribution directory, like you distribute product with the PDF inside its files. That's also possible. Okay, so the next type of documentation publication format, I guess, it's a built-in help system. So basically, you have your product and your documentation can be built in your product, like in its interface, in its graphical user interface or any other interface. There are cases where you have a command line interface with a built-in help system. So here's that. There are even APIs with some kind of built-in documentation. And the only good example I know is GraphQL, but there are probably more of that. So built-in help system is good because it's context aware. So while you're using the product, you might as well get the specific documentation on the feature you're using. That's great, right? But it can be quite limiting on what it can do on top of that. So basically, implementation of such a built-in help system, especially for graphical user interface products, it usually depends on HTML. So it's closed HTML, but it's quite limited in comparison because you do not usually track users inside your program because it's not a web browser. It works a bit differently. So yeah, you're quite limited with what you can use inside of it. You're quite limited with the metrics and tracing of your user's experience. What else? Maintaining it can be quite tricky because it's usually being built in your product. So you have to build your product with the documentation, but the updates for such a documentation are also built in. So you won't have outdated documentation, at least if you're doing your job right. And finally, we have text files. That's exactly the README file we had in our Q&A session, the first one. Basically, you can deliver these files with the distributive, as I said earlier. It can be in different formats, but it's quite limited to what it can do. I've seen such READMEs done as docx formats. I don't believe I've seen any in PDF format, although it's not like it is possible, so why not? But I never saw that. Most of the time, README files are lightweight markup languages, which we will get back to what does it mean. Basically, it's just text with minimum other formatting, just text, just pure and simple. And that's the reason why software developers like it, and that's the reason why just general audience might dislike it. They might not find it in the files because they don't know what to look at. They have minimum navigation capabilities in there. You can have headings, but there is no even faster way to navigate other than search the text file. So quite tricky, I would say. So not ideal. Not ideal. That's why it's so low. Although for developers, yeah, they relied on that a lot in the repositories. And finally, we have editable file formats like docx, RTF, and a bunch of that on top of that, like open source ones. Basically, what you see is what you get. Editors can be quite efficient, but yeah, it's not very reliable. And then anyone opening such a file can edit it and maybe do that unintentionally. So, and on top of that, it's not like just their mistake of typing something down in that document. It's tricky to actually open it in the very same way and perception as it intended to be, because sometimes in docx and RTF they can miss some font, they can depend on the system's settings or even software you're using because of different word processes. We'll get back to it later. So what they see might be different from what you see. That's such a problem. That's why PDF much better than that. So this is the last option here, although it's not terrible. It's just has its downsides. So let's start with the easiest one, I guess, but it's not the least powerful one, I would say. It's quite powerful. It's called Google Docs. You probably, most of you at least, heard of it, right? It's quite popular nowadays for the casual documentation or casual documents you might want to send to someone on do. Very easy, simple to use, like easy to start and get going. Yes, all that, but it's also quite powerful if you think about it. Because when you're sharing a link, you're actually sharing it to someone, a link to a cloud platform containing documents. So you don't have to provide the file itself, and the link will have the latest version of the document. But on top of that, it actually has its own versioning. Yeah. the stuff that Git does, it does also, like we have the version here, but it's simplified. Of course, it's rudimental, but it's still here and quite powerful still. So this button over here lets you to see all the different versions you have for the document, and maybe even see what's changed, and even restore the older version if you want. That's super powerful, super useful, and yeah, totally recommend. And also Google Docs can produce many different types of files if you want. You can click File, Download, and select like PDF, RTF, DocX, like many different formats. That's super useful. So you see, these very powerful features are built in and for free. Like, it's a great bargain. So I've seen a lot of technical writers actually using Google Docs quite actively to write content, and sometimes I've even seen storing content in the Google Docs. I would not advise sending like your users the link to Google Doc to, you know, consume your content, but you can work on it in Google Docs and maybe later on post it to website if you want. Maybe I've even seen, and in Canonical we do that. We do automation. So software developers actually using the Google Docs API automate the website to post the stuff from specifically, like pointed out, specifically hard-coded files. So we have a file in a Google Docs that contains the content, and we have a page on our website that publishes it, the exact same content. So if you go and change something in the file, the automation will change that page on the website. That's quite powerful, although I wouldn't recommend it. Not the most reliable and flexible solution, but it's totally doable. So Google Doc is a great solution, especially for simpler documentation, smaller documentation, or just, you know, if you're less experienced with all the different tools. Totally recommend. We have this software, you know, text processors, the classical ones. The most popular ones, I guess, well, most popular one for sure is Microsoft Word, which is a part of Microsoft Office suite, which actually very, very popular. Probably many people know and used it at some point. But it's, you know, a paid software, so it's proprietary format, DocX. You have to pay for the license. When some people try to ignore that requirement, but you have to pay, really. It's very powerful, actually. It has a lot of advanced features. So even if you used it quite, you know, easily, so like you would use Google Docs, you have to understand that Microsoft Word actually contains tons of features, like so many different features for automation, like scripting, and also even without scripting, it has tons of features like styles and all that. You can really work to some advanced documents, very big ones, very heavy ones, and it works quite reliably. So I'm not actively using it for the most recent versions. Maybe for past 2 or 3 years I wasn't that much of an active user, but it's definitely possible to learn like advanced Kung Fu in Microsoft Word, and there are courses, you can Google them easily. There are some advanced features that are quite helpful if you work in this format. So the limitation of DocX format is quite heavily implied here. There are some alternatives to Microsoft Word, which are listed here: open source and LibreOffice. Out of the two, LibreOffice seems a bit more modern with a bit more features, but both of these are open source and free. You can use them for free. They work a little bit less reliable than Microsoft Word, I guess. So there are some problems of compatibility. Something might break even. So just be advised, it's best to use, you know, just single suite for everything. If you work in Microsoft Word, send someone a file and they open in LibreOffice, there is a chance, it's not super high, but there is a chance that something will get broken. So just pay attention to that compatibility issues and accommodate for that. And as I said, PDF is a better format to distribute your documentation rather than DocX or whatever open source format like Oddity, open source and LibreOffice use. So here is that. That's a very interesting topic. CMS, or Content Management System. That's great stuff. It's not quite often being used for documentation, more like used for content writing, for website management, because if we simplify it quite a lot, basically it's a website to build a website. Yeah, that's how it is. So you have your web interface, like an admin portal of some kind. It's internal, so you have the authentication, you have to know the login and password. And this kind of admin web portal lets you change content on another website, like the public one. So basically, you have two websites. Internal one, where you have like a web editor of each page and a lot of things, and public one, which does not require authentication most of the time and has the content published already. That's the way it is. And we have multiple options here, like WordPress, Drupal, and Joomla, the most popular like programs that you can manually install on your server and use. You can self-host it. You can use some cloud services that will host it for you. There are some services that provide like software as a service solutions. So yeah, very flexible. And Squarespace and Wix are purely services. I don't believe they have like the distribution that you can install manually. They just provide the service that you can pay them and use the solution. That's it. So software as a service. That's basically it about CMS, but we will have the proper demonstration of how to use a CMS in our practical demo section. For now, we will switch the like inside the tooling section, the huge subsection of docs as code approach. It's huge, but I will try to go through it rather fast. So what is docs as code approach? If you're not familiar with it, that's the time and place you will learn about it. So we already talked a little bit about how we develop a program, how we develop software, when we actually write a source code of a program and then build it. So when we talk about the series of approaches known as X as in something as code, that's a similar approach when we try to represent something by just coding it. So we have a simple text file with some code that can be built into something else. That could be applied to, as the picture says, for infrastructure, for example, some virtual machines. We can have a declarative file stating what kind of virtual machines we want. We use that file with some program, and that program creates us the virtual machines or service. It could be service. You see? So infrastructure being created out of the code, which describes what we need. That's infrastructure as code. Network as code, the same approach. We can build like network gateways and networks themselves, how they interconnected, some rules and all that as code, as a file with declarative requirements. And yeah, we can use that file on a service on a software, and it will build us the network itself. And the same approach can go for the documentation. So docs as code is the approach when we treat documentation as we would treat some software. So we have a source code of our documentation, which is plain text file, most likely in a repository, like a VCS repository. And we basically use it to build our documentation out of it. And that's great stuff that actually opens a lot of possibilities. And we will talk about it just now. It opens us with the possibility of using a lot of tooling, professional tooling being used for software development. Because of how efficient engineers usually are with building software, we can actually use their tools like text editors. I already showed you VS Code and IntelliJ IDEA, right? No, I only showed you VS Code and IntelliJ IDEA, I believe. So we can use those text editors quite effectively. So they're quite advanced in editing. Even the simple plain text has so much to offer. You can search, replace, you can navigate through it, you can show the previews, like so many different advanced stuff, including the syntax highlighting, which is less important than documentation. So we can also use version control systems quite effectively, so because they were designed to track the changes in the plain text format. So that's exactly how we use them. That's super efficient, that's super reliable, and yeah, that's totally recommended in docs as code. We can automate with CI/CD in mind. That's super cool. I kind of showed you how CI/CD can be used to build your programs and told you at the time that it could be the very similar way used to build your documentation. That's true. We can use CI/CD to automate our documentation tasks, even building our documentation, even testing it, and so on and so much. We can automate tests of our documentation, like check spelling, check some links, check some code snippets, check that all the resources like images are in place and all of that. You see, automated tests are great. And we can also generate some of our documentation. That's super important, especially for API references, because they are quite long and tedious. They don't have this much of storytelling that you need to apply, manual effort to. They're basically just description of every possible function you have in the API and the endpoint and its parameters and so on and so much. So it's great to automate this, and we have OpenAPI that I already mentioned to do that. Sorry, just a cat. So the very similar way, we already had this slide before, the very similar way we build our software with a compiler interpreter into basically software from a source code, the very similar way we can build our documentation, like you see here, but we will be using something called static site generator or some other docs generator if it's not a website we're building. Basically, it uses a source code in some kind of syntax. We will talk about it a little bit later. We'll use design template, which applies consistently the design of our documentation, how it should look like, how every type of heading, every type of text should actually be performed, with which font, which size, which color, which position, which margins, everything. It goes into design template. So when we develop our source code, we only think about content. That will be important later. We'll get back to it. And the very same way we can build automation for the software, like I told you, we can build the automation for our documentation. You see, the program on the right of this slide became HTML file for the documentation portal here. So that's important distinction. But the content, it was plain text file it is still plain text files in a Git repository. So not much changed here. And that means a lot, because automation works completely the same for both software and docs as code approach. Like if you build software or if you build the documentation with docs as code, it's super similar. And that's the main workflow that we have in this approach. Basically, on the top of this chain, we have creation of a content in plain text format. So we have text, right, that we write, just plain text files. And I provided some extensions for such files on the right, like txt text files, or MD for Markdown, ADoc for ASCII doc, or RST for restructured text. Those are syntaxes we are using for docs as code, called lightweight markup languages. We will talk about them a little bit later. So we use those plain text files containing the content, like literally the text we have and all the samples, examples, whatever. We use the source code and store it in VCS and build it with some kind of a static site generator or other builder, and then we publish the result. And you see we have some branching here. So we can, instead of storing it in VCS, build it immediately, like manually build it out of source code. Yeah, we can. Nothing limits us there. We can. It's not against the law. But it's so much easier if we go on the left branch where we actually store it in the VCS, and the CI/CD does it for us automatically. Because that's way we get this picture. We just store our content, and our published documentation updates automatically for the latest version of our content in the repository. That's the best way to do it, but there is still a manual way, which is shown by this top right arrow. We'll get into detail at the moment of each of these steps. So let's start with creating content in plain text format. Like I said, there are some integrated developer environments that are best exactly for that purpose. They are supposed to be developer environments, so for software developers. So they are supposed to be used for some programming languages like Java, Python, JavaScript, Rust, and like a bunch of those. Yeah, sure, but why not use them for our text? They're still good at it. And on top of that, we have special syntax, like the lightweight markup language we'll be talking later, which are quite simple, and we can still use syntax highlighting. We can have all the helps that the IDEs actually can provide us with, like they can spell check. Yeah, really, they can. So they can work, and we should really use them in docs as code, because that's the best way, and I'll show you how to do that just in a moment. But you have to understand that those are professional tools. There are a bunch of features that we don't need for documentation because they are used mostly for developing software. But there are some advanced features that we might as well use, because they are great. All I'm saying, that's professional instruments, like a scalpel. If you know how to use it, you can do great stuff with it. So that's one of the easiest one. It's called Notepad++. I believe it's only available on the Windows. Not sure about macOS, actually. Probably not. So mostly on Windows, you have this Notepad++. It's quite easy. It's basically Notepad with a bunch of different features available for it additionally to that. It's simple yet very, very powerful. So totally recommend it if you're on Windows environment. This, on the other hand, it's I would say complete opposite of it. I would not recommend you if you don't know what it is. It's called Vim, or NeoVim to be exact. Well, on the right, we see the basically a console, like a terminal, with the NeoVim inside of it, and it's quite tricky to use, and it's, yeah, you have to know what you're doing to actually use it. It's really hard. For example, some people actually can't exit the program, the NeoVim, without Googling how to do that. It's that sophisticated. So not recommended for beginners, but still there, still an option. And you already seen these three pictures for Visual Studio Code, which is quite good. Yet again, left is for navigation here. We have some tabs over here. For example, the Git tab is right here. We can see the branch right here. This is our files that we have in our documentation at the moment. This is a source code of the documentation. And this is a preview of the documentation that we are seeing in the VS Code. And this is my favorite one, like I told you before, IntelliJ IDEA. The idea is very same. It's just different interface and a little bit different on features, but not too much. So we have these lightweight markup languages to be used in Dox's code. That's basically the syntax to use. So we don't just write a bunch of text, because it will be just a bunch of text in our documentation. We want images, tables, lists, some other features. I don't know, like sorting, no, not sorting, maybe aligning, like formatting a little bit. We want this text bold, we want this text italics, we want this image to be like central line, we want something, more tricky and advanced in terms of formatting and just how we present the text. Maybe so. These languages, they do just fine. They provide basic features for formatting, not advanced ones. You cannot do it very much like you would do in any what you get editor like MS Word or Google Docs. It's quite different, because what you do is create your content. The looks of it will be defined in a design template elsewhere, not in the same file even. So it's part of the build system. It's not here. So we are mostly doing the markup here, which is basically what the content we have and which type of content we have. For that purpose, we have only three options here. Really easy. We have Markdown, which is the most popular one, and have a bunch of tooling, like literally hundreds of different tools using Markdown, maybe thousands actually. And yeah, it's not the richest on features. Total recommend for beginners though. If you have more sophisticated documentation, you might as well use something else, which we have something else. We have ASCII-Doc and restructured text as alternatives. My favorite one is ASCII-Doc. I believe it's, I'm not sure about popularity, right? It's quite arbitrary here, but in terms of tooling, it's a bit better than restructured text. And in terms of features, out of the box at the very least, it is better than restructured text. So yeah, if you would to decide, I would totally recommend go with Markdown first because of how popular it is. And then consider other languages when you actually know what you're doing. This is how Markdown looks like. On the left, you have the syntax of typical elements. On the right, you have rendering of these elements as an HTML page. It's not much, but you can see that it's really easy to read on the left, even in the source code. So yeah, you don't really need a lot of previews most of the time. This is ASCII-Doc syntax, a bit different, yet still quite easy to read. And I would point out a few things here. For example, we have this heading of the second level, so it's not the title of the page right here. This is the anchor that we can use to link to that particular heading. This is the usual text, like just you see it rendered right here on the right, the usual text. But this is an important piece here. This is an include directive. So you don't see that directive anywhere in the rendered text, but instead, in between this fetch value and two fetch value pieces, like the heading and the text, between them, you see this piece. For this example, use a database. But you don't see that text anywhere in the source code because it's being included from a different file. That's what that line is about. We're including the contents of that file here. You see? That's super cool feature that ASCII-Doc and restructured text have, but Markdown actually lacks. Markdown can be extended, okay, with many different features, but that actually comes with the price of being inconsistent across different implementations of these new extensions. So yeah, I do prefer ASCII-Doc way of doing stuff, and that's it. And that's a code block, that's an output, also another code block, basically. That's another include, that's another heading. You see this one of third level, so it's like a nested heading. Quite easy to navigate, really. Nothing too hard. This is restructured text. Well, I would call it a bit less direct, a bit less pleasant to see, maybe, but still quite easy to understand what's going on. We have our code blocks, and yeah, it's all right there. It's not like too much. You can navigate it throughout quite easily, so without a preview, but still the preview usually with your IDE comes as a plugin or something. One honorable mention, which we will have a demo about, is pandoc, which is used actually to convert documentation from multiple formats to other formats. You see, it has a quite long list of supported formats. Basically, you can Google the pandoc and find that on their website a huge list of formats, and which it even mentions which formats they can use as input, which formats are as output, and so on and so much. Super cool feature, and I will show it on demo how to use it. Super cool software, rather. And it's free. So the next step, after we created our plain text content, we store it in Git. And we actually already had a slide about it. You remember this? Pics? Like, we already had all this. So basically, we have our command line interface client. We have our GitHub desktop. We covered them already. We have these branches that we covered already. You remember the chess, my favorite analogy. So the very same way we use VSS as source of truth for the source code of software, we use Git to track our documentation, like literally on the image of GitHub, right here, right now, on the same image, you see the change in some text. It's not a Java code. You see, it's not a Python code. It's just text in English. And it's super reliable, super accurate, and it's very handy in transparently tracking all the changes. And yeah, just totally recommend. And it's not mandatory to be exact in Dox's code, but it's almost mandatory. Like, it's so much better with it. Now we have the build stage, which is quite tricky because we have to decide which tool to use, which software to build our documentation, and there are quite a lot of nuances there. So there could be a lot of detail. You have to do proper research to understand what's going on. Sorry, my cat requires some attention. Oh. And you can consider this particular stage of building your documentation as a black box, especially if you have some engineers who actually implement that for you instead of you. Like, they already automated the building stuff, so you already have this automation in CI/CD. You just need to provide content. You just need to update the content in the repository. In that way of thinking, and that's quite popular actually, you will have the black box approach when you don't actually go inside the documentation builder, or at least you ask your engineers to do it for you, to change something, but you just commit your text, your images, your other resources required, and you work with the text just the way we just discussed. And the best part of it, this same automation, this black box, can produce for you any format you need. Even if you need simultaneously HTML and PDF in some other format like docx, it will produce them for you. Now, it will be quite tricky on the implementation side, but you can guarantee that it's the same content being produced, because it automatically gets your content from the source code and puts it into different, design template. That's it. That's all it does. Really, it's not that hard for software developers to build such a system. But if we go inside the black box, we start seeing these names of what software actually being used to generate this documentation. So in terms of producing HTML, which is the most popular and preferred format, we call such software static site generator. And like the sole purpose of the static site generator is to produce HTML pages. That's exactly why it's called static site, because HTML pages are static. They don't have the logic of JavaScript or any other programming language. And similar to interpreter or compiler in software, you use static site generator as a way to convert your source code into the documentation. That's the way it is. For Markdown, we have hundreds of them. Like I told you, these are just honorable mentions, like honorable mentions of the most popular. I know Hugo, and it's super easy, super fast to use. Totally recommended for your first project. Markdocs, not as fast, but I think it's even more simpler. Like it's even simpler than Hugo. It's so user friendly. It's surprising. Well, Jekyll, it was quite popular like 10 years ago or so. It's not as popular nowadays, but you still see it a lot as legacy in a lot of products. It's a bit tricky and brittle, and yeah, you probably need your engineers to help you with that one. And you also have like Docosaurus, and as I said, hundreds of others. Like those are just examples. For restructured text, you might want to use Sphinx. It's not the only tool, but it's like the most popular for sure, and the other tools are not that great. So Sphinx is totally recommended. Just consider using it. But to be actually good with producing documentation in Sphinx, you have to know some Python. Or you can use your software engineers who actually know Python better than you. Just be advised, Sphinx is a bit more of a manual approach in terms of you using Python to do some stuff. And AsciiDoc, yeah, it has some alternatives like AsciiDoctor and Antora. I would recommend Antora, especially if you do HTML stuff, basically websites. Antora is quite opinionated, so there is an extensive documentation of how to do stuff, and you should actually follow it instead of trying to invent new bicycles, because yeah, it's quite opinionated, and it works great if you follow the the requirements, if you follow the approach. This is how it looks like to deploy a new documentation set with Hugo. Basically, that's all the commands you need. Like literally, these are the commands. Obviously, you need to install Hugo first, but otherwise, literally, I tried it yesterday and it worked. We just specify Hugo new quick start. Basically, creates a new folder quick start with the basic set of files needed. We navigate into that quick start folder we just created. We initialize Git repo. We add a submodule with the theme, with the design template to be used to build it. And then we just change some settings, literally here. We copy the files in the required directory, and then Hugo Serve actually builds our documentation. That's great. I believe we have a practical demonstration of this particular workflow in our demos section. The CI/CD part, the automation part, it's super interesting and super important, but it's basically done by engineers, so you don't have to go that big on understanding. You don't have to implement it yourself. You have engineers who actually do that daily for their software development. You can ask them to do similar stuff for documentation. You see, you just need to understand what exactly you want to build, and they will automate it. That's great. So you ask their help, they will help you with that, and you will have automatically built-in documentation. That's great. We have some pros and cons here for Dox's code, but it's quite long. I'm not sure I want to go through all of them, so I would highlight just a few of them. For example, transparency. Via Dox's code approach, we usually use plain text files. You kind of change these files, and you track them with VCS most of the time. Like it's rarely being used without version control system like Git. And the transparency comes out of that. You actually, it's very, very hard to change something and not like document the change anyway on the version control system. Like it's hard to hide it, really. There is only so much ways of doing that. And Git is very, very good to track all the changes and to track who changed it and when and how and what is the history of these changes. And if you need to revert these changes, everything is super transparent. And with the same features, it becomes also a very good tool for collaboration, because you again, it has your branches, you can merge with branches. It's super, super cool. And yeah, you have to learn it, of course. So totally recommend passing through some of the learning tutorials, courses on Git, but it's so much helpful for Dox's code. You cannot overestimate it. It's just so cool. And scalability. I've successfully used Git in both like huge companies with a lot of developers working in the same repo, with a lot of technical writers even working on the same documentation. And with the same level of success, I have used it as a sole technical writer, like as a sole contributor. It's still very good at scaling. It's still very effective, even if you use it alone, and especially effective if you use it like with dozens and hundreds of contributors. It's super, super scalable. So yeah, it's great on any scale, even if it's huge. Well, other great benefits here, I would maybe even highlight the abundance of open software here in Doxys code, because it's close to developer environment. The developers tend to develop great tools for themselves and make them open source, so they are free. You can use them for free. It doesn't cost you anything, really. Yeah, for the con side, we have additional efforts of learning how Git works, how lightweight markup languages works, how to use IDEs, and all of that you have just seen. It's a bit steeper learning curve, right? You have to push your changes into the Git repository. It's harder than Google Docs, that's for sure. You have a lack of what you see is what you get editors, like Google Doc, for example, right? You change something, you immediately see it right in the line you just changed, how it looks like in the final end goal. It's not the case usually for Doxys code because lightweight markup language is plain text. It will be rendered with the design template, and you can have a preview maybe, but a preview is not the same as what you see, what you get. So yeah, lack of that. And perfect results with Doxys code can be quite tricky, although it comes from the open source nature of things and the way you can set everything up. So basically, you can fine-tune anything and make it the exact way you want it, but it can be tricky to fine-tune it. You can provide the fast results at first, the way the developers of the tools wanted to make it, but if you want some adjustments, yeah, you can get into detail and try to wiggle it a bit, test it a bit. It takes a while. So yeah, fine-tuning requires effort. This is my comparison. Obviously, I'm a bit biased in the favor of Doxys code, as you can see. But yeah, version control, collaboration, automation, integration with software development, scalability, open source tools, everything is great. Maybe collaboration is a bit sophisticated, is a bit more like challenging in terms of getting people who are not familiar with Git, repositories, plain text files, and lightweight markup languages. Imagine some manager who doesn't know any of these, and yeah, collaborating with that kind of person would be tricky. But yet again, since we're talking about software development, most of the time you're collaborating with some software engineers or even managers. They actually know that stuff because they're managing the software development teams already. So yeah, for software development, it's not that bad. For other fields, it can be tricky. Let's talk about synergy with software developers real quick, because we are a little bit behind our schedule. I want the practical demos to be actually to be able to present them. So professional tools, we have lots of professional tools like IDEs and Git. They're very, very powerful, but you have to learn how to use them properly to be efficient with them. That's obvious. Additional sources of information. Git is actually a very, very rich source of information. So it's a very transparent system, like I told you, and it's designed to be, to help you collaborate with other people. And it's like there is so much you can just get from it. So you have a repository with your software product, which contains all the source code of it, right? So the source code already is source of truth. And as we told you, we discussed already, I mean, it's the best one. It's the most accurate one. If you know how to read it, it's like you basically reading how it works. That's it. But it's tricky, I understand. So we have some others. Internal documentation, for example. These README files they store in their repo. Why not? There is even a built-in wiki system for Git. So yeah, you can use all that. The release notes usually also stored somewhere close, like a changelog or something, to the source code. You can use those to track the features and which versions they appear, which features are there. You can find links to PRs, like pull requests. PR means pull request. So the pull request is the way you merge one branch into another. And the interesting part about PR, and we will go actually into creating a PR in our practical demo session like just in a bit. The interesting part is actually contains all the information you need to understand the change, because it has a like literally tab called files, which tracks all the changes that are implemented by this PR. And also it has comments. It has the instruments to discuss these changes. So if there is a pull request, add a new feature, the chances are developers already passed a review on such a pull request and discussed these changes, how they work and how they can be tested and why they are working that way. That could be very, very helpful for your documentation. So yeah, pay attention to it. And you have commit messages, commit history, blame, diffs in these commits. So yeah, all that is very helpful to track the changes and to see the history of these changes. It's super transparent, as I said. Automation, we talked about that a bit. So you can automate the building of your documentation, but so much more, like syntax highlighting, error correction, content generation, screenshot updates even. That's advanced stuff. So not from beginning, but eventually, yeah. Testing, you can test your documentation. Since it's a plain text format, you can test for spelling, but you can also test the build-it documentation for some links, whether they're broken or not, some images, even test how the build works, whether it's like looks the way you want it to look. Why not? And that's about the tooling. That we ended the tooling section. So we're starting the processes section, talking about what we will actually encounter working on this field in terms of organizing our work. And this is the last section before the practical demo. So we'll go through that a bit fast to have time for demos. We have processes of that building our documentation, but basically, since we work so close to software developers, we might as well inherit a lot of practices and best practices, I should say, from software development itself. So starting from using Git version control system, which is actively used for Doxys code, well, you don't have to use it, but it's very, very efficient, and there are a bunch of tutorials how to do it properly, and it's probably a good idea in some cases. In other cases, you can just learn how to manage your work, how to track tasks. For example, there are some instruments like Jira and other task trackers. You can use agile approach, which we'll talk about. Waterflow approach, also we'll talk about it. This kind of stuff being battle tested by software developers, and it's very efficient. And I mean, the point is this solution works for sophisticated tasks of software development, especially if we do Doxys code, it will work for us. If we are not doing Doxys code, it can still work with us. And on top of just using them because they're efficient, these approaches actually, by adopting them, you will be in harmony with software development team. If, for example, you and your developers both work in Agile with the same sprint, taking the same week, you can literally work in the same pace, you can schedule, you can plan, you can do everything the very same way developers do. They will understand you better, you will accommodate for their needs better. That's so much synergy in the way you build your processes. And that's where we actually need to start talking about Agile, which is a methodology that actually emphasizes flexibility, collaboration, and iterations. So you basically iterate fast, and each iteration being deployed. That's the practice of it. You have the repeated cycle of Agile on the right, which is quite close yet to what we have. And basically, that means that you have something like a sprint. Sometimes it's 1 week, sometimes it's 2 weeks. And you try to fit all the cycle inside that sprint. So basically, you have, for example, if you have 1 week sprints, you feed all the processes in this cycle inside this week. So by the end of the week, you deployed something, deployed a new version of your software or your service, or in our case, a new version of documentation. You kind of deployed some new content there, new page or piece of page, or just documented or fixed something, anything. So basically, you deploy each sprint, and you go through planning, designing, developing. You do all that each sprint. And that helps you actually iterate over and over again and plan it thoroughly, but plan it for the sprint itself. Obviously, you have some long-term planning, but this agile approach is agile, not because of some clever wordplay, but literally it is used to be agile, to adapt to changing environment. So that's why it's so good for software development, because you have this feedback, and the way they accommodate for feedback on their software and testing and user feedback, the same way you can accommodate this same feedback and testing for your documentation, for the benefit of your documentation. So that should and can work greatly. I work that way, I assure you. You should build this process, though. This is a very high-paced environment and rhythm. You should understand the regular meetings and their importance. You should declutter a little bit. But there are so many different literature and books and articles about how to do that process. So yeah, probably you should learn from them, not from me. Just be aware that it's very, very popular. Many people implement it and they do it differently because it's agile. You can adjust it for your needs. Yeah, here is that. And there is a waterfall, which is opposite, where we have a linear plan. We kind of plan in a more long-term environment. We plan each step of the process, like we're doing that, then we're doing that, then we're doing that, and we follow the plan. That's it. Very simple. It's considered to be part of classical management, and each phase is supposed to be finished before we move on to the next one. Well, sometimes it can intersect if we're in some asynchronous process of approvals, reviews, that kind of stuff. But still they're linear, so they have some consecutive order. And it can be used for both software documentation and software development. Although for software development, it's most likely to be some combination of waterfall and agile rather than pure waterfall, just because agile works quite good for software development, although there are some theories about that. What are the benefits of waterfall? It's, as it's stated, like clear project phases. You have a clear advanced plan without this reiterative approach each week or each sprint. You have comprehensive documentation of your plan, basically. Yeah, your documentation also should be complete, but in this particular slide, we mean that you documented the progress and you kind of understand in which point of plan you have at any given time. So if it's a week 2, you understand, okay, I'm here, I should be able to start this task already, and I should be finished with this task already. So it's quite easy to understand what's going on and what's your progress. Predictable deadlines, and you kind of focus on the end goal here, not the reiteration, not the adapting to changing environment, but reaching the end goal in the established plan. So different approach, I would say. This is an important slide about stages that actually, these stages are implied when you go through documentation process. You kind of need to go through all of them. Well, sometimes you can omit them, especially for simple documentation, but they are important and you have to understand the importance of each step. That's why we will discuss them now a little bit. Initial research and scoping. You basically need to research your task and understand what it implies. How much documentation, what kind of documentation, how much you need to write here. Sorry, I have troubles with my voice already. So basically, your initial research should help you to scope the task, to understand the size of it and what exactly you would have to do that to complete it. And then you go into planning. You don't do the task right away, right? You plan it for the future cycle, like future sprint, or if it's a waterfall, you plan it for some future stage of the plan. And after the planning, you basically wait for well, you not just wait, you do other tasks, but when the time arrives by your plan to actually do the task, you start your work by gathering information, like additional information about the task to actually produce the documentation. And also the part of this process is interviews. So it's important for you to gather as much information as possible without the interviews or before the interviews, rather, as I told you before when we discussed interviews. So yeah, that information, then have your interviews, and then you go into content creation. You write your initial drafts of documents and so on and so on. You basically create your content. As you notice some blind spots, you iterate with software developers or SMEs, that kind of stuff. But the drafting here is not exactly for you. Well, what I mean by drafting on the fourth element is actually you can ask your engineers or your developers or your SMEs to draft you the content. In some sophisticated areas, and as I told you, in some companies, it's even practiced for engineers, for developers to actually write some content that will be part of the documentation. And that's exactly it. You ask them to draft the content, and then you rework it, maybe edit it a bit, maybe you will rewrite it completely. That depends on the quality of the content and the requirements and so on and so on. But yeah, that's what about it. So you either create content yourself, the initial one, or you ask them to draft something up and then you go from there, but that's it. When you have this some kind of draft, some kind of idea that well, it's not finalized yet, but we have something we might want to show. You go through reviews, and you can have different types of reviews. There are some technical reviews when actually SMEs and other stakeholders, anyone, can check that your documentation, your draft, your content is accurate enough, is not misleading, and it actually achieves the goal in mind. You remember the three main questions? So we have the goal always in mind. We try to achieve some goal with this communication. So they check that. They check technical details, whether the comments you're using are right, whether the information you're providing is correct, whether everything seems like in place, nothing obvious at least is missing. That kind of reviews are called technical, but there are some different types of reviews. For example, there are peer reviews when you're actually being reviewed by your colleagues. And that's actually usually falls into category of editorial reviews. So usually editorial review is done by your colleague, like technical writer, or like a dedicated editor even, who actually check your, well, sometimes spelling, sometimes just wording, and whether you use your style guide correctly, that kind of stuff. So yeah, and you, after the reviews, you actually get into the position to get approvals for the content. Since we kind of want to publish it, user-facing documentation usually goes through some kind of approval process. That's quite important. You cannot miss it. And yeah, it's a bit different from reviews, but it's different for every company. So yeah, it's specific to your company, I guess. Then you publish it, whatever means publishing you use, HTML or PDF, you produce it, you double check it just to be sure, and you deliver it to anywhere where your users can find it. And then post-publication support. That's super important, that you don't drop your content as soon as you publish it. You have to ideally gather some feedback and metrics from it, see how it lives by, see how users actually interact with it. So yeah, in some cases, when you understand that some content actually was outdated or no longer required, you can even delete it as a part of post-publication support. You just double check your documentation that everything is fine and whether anything needs amending. And that's where you start again with initial research if anything needs to be modified, adjusted, right? We will have the CMS demo first. Let me see whether you'll see if I do that. Oh yeah, you can see it. Okay, cool. So what we have here, we have some website, fancy one, right? What we want is to see how to edit this website via a CMS, so how it works. So basically, we have a public website here, and next step, we will go into admin portal to change, well, in particular, this title we just selected. So we go to another tab where we actually already opened the admin website. This is how it looks like. I'll place a pause here. So we have this pages section. You see, we have a lot of sections on the left, and by the by the icon up top, you can see that it's a WordPress, and that particular admin panel is of a WordPress CMS. So we go into pages section, and we go into all pages, if I believe, page inside the admin panel of WordPress. This is how it looks like. We select the page we want, which is a home page. Yeah, this one. We open it here, and it opens not as like a home page that everyone will see, like the public page, but we will see it in this editor. So basically, we have this editor with quite a lot of functions. We can switch to that mode, which is a classic mode of showing us the code, which is quite sophisticated, like markup. It's not graphical, but bear with me, it's not the only way we can do it. Most of the time, we do it like that. So it's a visual. What you see was a get editor. We yet again locate what we want to change. For example, this title, we want to change it. We go there, we click the pencil button, and we change the text. That's it. That's how it works. It's a web interface, like a website, web admin panel, that lets you change your public site. See, a website to build a website. That's how I described it before, and that's how it looks. You don't actually need much more of what we just saw. Just scroll down, and here we are. with the text we just entered. That's how CMS works. Literally, you just have the admin side and you use it to adjust like whatever you have it on your public side. That's it. That's how it works. Let's move on to the next one, which should be this one. Yeah, docs as code example. Let me start. Yeah, now it's visible. So what we have here is IntelliJ idea and me changing something in our documentation, like not my current documentation, but the one I was working for like a year and a half ago, I guess. So basically what we want is to change this sign less than equal into literally just a less sign, the angle bracket, and the equal sign. So you see it's a bit different syntax because we specifically say which symbols we should use for the syntax of a query language. We should not use that one. So it's a mistake that we need to fix. So here we're changing that particular place of the documentation. And we have the preview on the right, if you can see. All we do here is fix that symbol inside the text file and then build it locally to double check that everything builds correctly, and then push the changes into the repository. That's exactly what I will do here. So I changed the symbol. That's what I just did. That's the correct syntax with the pluses to just, the direct quotation that's required by the syntax of the Lightweight markup languages, so don't mind it. This is a command line interface, basically a terminal, where I run the command pnpm build, which launches the script to build our documentation. It's, yet again, one of the automation pieces that build it by our engineers. In this case, our DevOps actually build the automation. So all I know is that I need to run pnpm build. I don't exactly know everything that it does and every technology behind it. I know the command that my DevOps told me to build the docs. That's what I'm doing. I'm building the docs locally. You see, I'm waiting for it to build without any significant errors for me to understand that everything's correct, everything's fine. It will build on the real production environment. I'm just waiting for it to build now. Don't worry, it will build. I watched the video. It all ends well. Yeah, it's built. So basically, we have the file here locally. We can open it and double check that everything looks fine after the build. That's a local file. You see in the address page, we have the local address, not some URL, HTTP address. I go to the page and I check how the sign looks like. Here it is. You see? Now it's the correct one. Just a list sign, the less sign, the angle bracket, and the equal sign. That's what I wanted. Exactly that change. We double check that everything's fine. We can now push the changes to the remote server, to the version control server, to the Git server, specifically to GitHub. So I'm using GitHub desktop yet again. You see the familiar interface I showed you already. You see that it already tracks all the changes in the local repository that I have, exactly the changes we were talking about. It is highlighted in the middle section here. On the left, we have the file highlighted, which changed. And on the top, we have the repository selected, the branch selected, and the only button to fetch. It's not the button to push yet because we did not commit the changes yet. The commit happens on the bottom left. So now we will do just that. We will write the commit message because it's mandatory to have a commit message to describe what happened. And then we push the button to commit, then we push the button to push it to the repo, push the commit. Here we're writing some vague and short description of what happened here. It's called the commit message. And then we commit. We commit it locally, and then we push the button called push. And we'll push the same commit, but to the remote repository, to the server. And as soon as it lands there, the automation will build it into our production website. So it will be published in like mere minutes. That's how it works. Okay, let's move on. This is how we contribute to a GitHub repository. Well, in case you don't know, some people might already have contributed something, but I feel that might be useful for some. So what we have here is some random repository of mine. In this particular case, it's a Hugo quick start repo I made, just some experimental stuff, nothing too serious. And I want to change its README file right here to add some basic description at the very beginning. It's super simple, but I'm trying to do that from another account of mine So like not as author would change its own content, but as any one of you could go there and do that exactly the same way. So that's how you can go to any repo, like public repo actually, on the GitHub and change something, at least not exactly directly change something, but suggest the changes, because at the end of this demo, we'll create a pull request. So basically a request to make changes to the content. So that's how we do it. Basically, we have the repo, we have the file here, that's the repo. We have the, yeah, I'm just showing you the file. We have the, yeah, just showing you again the source code of the file. That's what I'm doing here. We get back to the repo. We use this fork button up top, and we click create new fork. That actually lets us to choose a name for it. We don't want to rename it now, but you might as well change your own fork of the repo. Fork is your own like parallel universe you exist. You see, it's like completely yours. Your fork, your rules. You can do it whatever with it. So we create our own fork, and since it's our own fork, it's full copy of the origin at the moment, like a snapshot. But we can do anything with it since it's our own. It's now our own repo being forked. You see, it's written right here. It's forked from and the origin link to the link there. So now, since it's our own, we can go and create another branch in it. Just because we kind of work in branches in Git, so I wanted to do it proper way. So we created that branch called new, and then we just go and change the file. I click here code to see it, but to edit it, I actually need to click the pencil button on the right. Unfortunately, it's not in the area that's got recorded. So keep in mind there is a pencil button on the right. Now I just add the content I wanted. You see, this is a simple demo for Hugo static site generator. That's it. That's some example I wanted to show you. And then we have a commit button, which actually, yeah, unfortunately, it's also not being visible because it's too far on the right. And which asks me for the commit message. You remember the commit message? Short description of what happened. So I add some commit message to the like update and file name, which is the default one. It's correctly assumes that I want to use the current branch, which is it's called new. So I just push I just commit it right directly through GitHub to the remote repository. It's not being committed locally and then pushed remotely. It's being committed to remote right from the start, because I'm using the web interface of GitHub right now. This is a GitHub web interface. Now that I committed it, there is a, it's in the correct branch, which is new. It appears at the very beginning of the page, a big admonition, a big note that this new branch, like called new, has changed, just recently being pushed, and there is a big red button, a big green, button, compare and pull request. So we can and should use this button to create a pull request. And in this pull request, we can actually see what's being like requested, from which branch to which branch the changes are being merged, or at least requested to be merged. So I double check that everything's fine. On the left, we have the original repository, the main branch, which is like the main. We have the arrow, little arrow showing which direction the request goes, the merge goes, if we successfully merge. And then we again check the repo, which is the repo we made changes, and the correct branch, which is a new one, like literally called new. This is what we do here. So we double check everything's going on, everything's correct. We can add some description down there. We actually might as well add it. Just add some text describing what happened and what the details, why do we need changes. Every repository can have their own idea of what should go there. So just describe what's going on and why. And then push the button, create pull request. That's it. That is done. You created pull request, and the author in the original repository which you forked will now get a notification that someone actually created a pull request. You see it's up there, the tab called pull requests, and it now has the number 1. So they literally have this interface in the GitHub web interface to check all the pull requests that they have. And they have this file change tab inside the pull request, to track all the changes that are suggested by this pull request. So it's really, really easy for them to review the changes, to approve them, to push the button, to merge it, because they have the access to it. You see, to the button. I don't have the button to merge it here, but the author, another my account, actually has this access. So they can change it now. They can review, and if everything is fine, they can merge it. If something needs to be changed, adjusted, they can use the same interface to create comments on the code in this pull request. So they can ask you around, like, why do you do that? Or let's not do it that way, let's do it that, like, other way. So they can just like have a proper thread here discussing these changes. Okay, the next demo will be about the Pandoc software I was talking about much earlier, actually, about converting different types of documentation, and it's especially useful for these lightweight markup languages used in DocSys code. So yeah, you can find on the pandoc.org website. The software itself, it's free because it's open source and can be used for all the lightweight markup languages. So yeah, feel free to use it. And the command to use it actually quite easy. We have a pandoc to call it in the terminal. Unfortunately, it's command line interface only, so you have to use the terminal. Then you use the F parameter to decide from which format you are converting, like from. So I selected docbook in this example. For the ASCII doc, it's a relevant format, docbook and ASCII doc. I selected T as a 2. Format 2 convert to which. I selected T as markdown strict for the strict syntax of vanilla markdown. And I also selected a file, the source file, to be converted, main XML. And with the parameter O or argument O, I selected the output file name. So the output would be main.md in this case. So this is how it looks like the command, and this is how it looks like with the demo. Basically, I already opened the terminal in the correct folder with this README file. We just changed actually in the last demo. So I just making a, output in the terminal to show that this is the file. Yep, this is the file. This is the text we just added. So now we use the pandoc command. Pandoc O, the output, pandoc F from, pandoc T to, and readme md as a source file name without any arguments or parameters. So basically, we have the pandoc to use readme md as a source file, and we explain that we want to produce some other format from Markdown to docx with the output file named output.x. .docx, sorry. That's exactly it. That's it. I just ran the command and it just produced the file. I just opened it in LibreOffice. Here we are. That's the file. Compare on the left the lightweight markup language, and on the right we have the converted docx file that we just created with the pandoc. It works really fast. It works great. It does not produce perfect result. Okay, there will be some errors, but there are a bunch of actual fine-tuned parameters that you can learn about in the Pandoc's documentation to fine-tune the conversion process, so the amount of errors will be significantly less. That's super nice to have. I totally recommend. And that's a real-life example. I actually used Pandoc to convert some documentations. That's example of some documentation task you could have, like an advanced one. So the task at hand is I joined a company, not a company, a team in a big company called VK, and they had this old documentation stored on Confluence, which is a knowledge-based management system, and the documentation was stored as docx files and PDF files right directly in Confluence. So no proper version control, just a bunch of files. You download them, you change something, and you upload them back instead of the old ones. And yeah, that's terrible, right? Because you have to use like the file names to mention the version of the file to understand whether it's a new one or an older one, something in the line of. It's very manual. It's very time consuming, and there are a lot of errors that can happen. Like, yeah, it's not great. So the newer system that I could come up with is using Pandoc. I converted all the docx files which we were using at the time was MS Word to work with the docs, and you then use pandoc to convert it into ASCII doctor syntax, ASCII doc rather syntax, so a doc format file. And to be precise, for you to understand the challenge, the amount of documentation I was converting at the time actually was quite big. So we're talking about like 300 to 400 of A4 pages in multiple, like around 10 maybe different docx files. So quite a lot of documentation. Some of the documents were quite big with a sophisticated structure and so on and so on. So pandoc did like good job. Not perfect, not even great, but good job. But there were some real problems with the headings, with the lists, with sometimes even tables. So yeah, I had to spend some additional time and amend these parameters that I spoke of for the pandoc converter to actually use specific syntax of idoc and the features to change some parameters of how to do stuff. Basically, fine-tuning parameters to improve the results from just okay-ish to good. So yeah, I still needed the manual review of the whole content that we arrived these, but it was like good enough. So a light review of all documentation that took me about a week. Sorry, it's just a big documentation. It was sufficient to actually get there. So I spent literally about a week because the conversion process itself is like 15 minutes, maybe half an hour. So I took a week and yeah, I converted all the docs and it was great. But I converted the docs with pandoc to adoc lightweight markup language. It's not like a publishable format, right? Our users will not read adoc text file. So what we needed is some like building system and delivery system. And what I arrived with is actually, I used ASCII doctor at the time to build a PDF file out of the adoc. Out of each adoc, I built the PDF. And this PDF was delivered then to S3 storage, which is like object storage to actually update content real fast and reliably. So we created a link where you could download the latest version of the object. That's it. So we had a link by which we can download the latest version of our documentation, which was distributed in our Confluence as the source of truth for documentation. That's it, really. So I had all my content in the Git repo, of course, and the CI/CD later on by our DevOps used the same Docker container with the same ASCII doctor that I arranged for manual deployment, used the same approach to build it automatically. So in publish to S3 storage, that's it, that's the whole story. This is how it looks like. So basically we have our Docker container containing the ASCII doctor solution to build the PDF and the PDF template. And when you use that with the input of the source code files in the ASCII doc format, obviously, and some other resources like images, some pieces of code that might be inserted, and yada, yada, like all the resources required. Not many of them, actually, they were, but still quite some, I don't know, like dozens of images, I guess. So we use this as an input, we use a Docker container, and we produce as a result a PDF file, which is exactly what we're looking for. And all that automated looks like that. We kind of push the content changes to Git, and it's fire and forget. As soon as you push the content, you might assume the CI/CD will try to build it and publish it. Well, it might fail, of course. There might be an error that prevents it from building successfully. But again, DevOps guys, they usually build this notification system. So if there is an error, you will get a message. Well, in the worst case scenario, you go there manually after like 5 to 10 minutes and check whether it was published or not. So that's it. Some additional resources for you to consider. We have like another video by me where I compare these lightweight markup languages. It's a part of open documentation hours we do in our canonical like documentation academy. You can check this out. We have also a huge catalog of static site generators on some website called Jamstack. It's a long story why it's called that. It's not our site. I'm just saying there is a huge catalog there, so you might as well check that. Especially if you're selecting these markdown static site generators, as I told you, there are like hundreds of them. So it's really hard to select one particular of them. And there is at least a catalog. Some selected static site generators. Yeah, here and now we have Markdown, as I mentioned, Hugo and Markdocs, and we also have ASCII doc and restructured text recommendations here, like ASCII Doctor, Sphinx. I probably need to add the Toro link here, but you can find it easily. What else? We have Pages on GitHub, which is quite a nice service that actually lets you publish your documentation as Docs Code approach easily. So GitHub is free, and this particular feature is free, and you can even host on GitHub through this way. So it's great. We also have a Pendoc, I already mentioned it, but we also have a Diagram as a Code Solutions, Plant, UMail, and Crocky. You might as well check them out. And some blogs, I put it at the very end, just, if you want to read something additional.